Hello? 1, 2, 3, hello. And let's do this stream notification here in Discord.
Hello there.
Hello, Gold Monkey, hello. How are you doing? How is your game? You did any progress? Alright, let's get started here. I am going to do Advent of Code. It looks like people are saying that this one is harder than the previous days. And if we take a look at the leaderboard, then it took people to about half an hour to fit the 100 spots on the leaderboard compared to yesterday, which only took people 7 minutes. So yeah, did you solve it already? All right. Let's see what this is about. You haven't attempted? All right. So we're going to open Advent of Code. On day 5, part 1. Let's see. You take the boat and find the gardener right where you told he would be, managing a giant garden that looks to you more like a farm. You will let me solve it, so you will have something to copy paste. I mean, uh, are you working on your Bevy game though? I thought you said that you're going to participate in the Bevy jam here, right? We had to stop the water because we ran out of sand to filter it with. Right now, no, you're about to go to bed. Yeah, I mean, do you have any progress? Or did you not get started yet? I can't make snow with dirty water. Don't worry, I'm sure we'll get more sand soon. We only turned off the water a few days, weeks. Oh no. His face sinks into a look of horrified realization. I have been so busy making sure everyone here has food that I completely forgot to check why we stopped getting more sand. There's a ferry leaving soon that is headed over in that direction. It is much faster than your boat. Could you please go check it out? You barely have time to agree to this request when he brings up another. While you wait for the ferry, maybe you can help us with our food production problem. The latest island almanac just arrived and we are having trouble making sense of it. The almanac, your puzzle input, lists all of the seeds that need to be planted It also lists what type of soil to use with each kind of seed, what type of fertilizer to use with each kind of soil, what type of water to use with each kind of fertilizer, and so on. Every type of seed, soil, fertilizer, and so on is identified with a number, but numbers are used by each category. That is, soil 1 to 3 and fertilizer 1 to 3 aren't necessarily related to each other. Not much. Was very, very tired today. Couldn't concentrate without just wanting to fall asleep. Okay, I see. It happens. Seeds. For example, seeds. Okay, let's just copy paste the example immediately. By the way, right? Day 5 example. All right. So we have the almanac starts by listing which seeds need to be planted. I guess we can just do something like this. The almanac. But then I need to scroll horizontally here. All right, I need to scale down then. The almanac starts by listing which seeds need to be planted. This, and that. The rest of the almanac contains a list of maps which describe how to convert numbers from a source category into the number in the destination category. So like seed to soil. So we can convert a seed into soil. And then convert soil to fertilizer. And then convert fertilizer to water. And water to light, light to temperature, and temperature to humidity, and humidity to location. So we have a chain, or do we have a graph, is my question here. The gardener and his team know which soil to use with which seeds, and which water to use with which fertilizer, and so on. Rather than list every source number and its corresponding destination number one by one, the map describes entire ranges of numbers that can be converted. Each line within a map contains 3 numbers: the destination range start, the source range start, and the range length. Okay. Destination, source, and length. Consider the example of this. So we convert into 50 from 90, so 98 means goes to 50, and 99 goes to 51, right? Yeah, with this information you know what seed number 98 corresponds to soil number. Yeah, okay. The second line means that the source, okay, any source number that are not mapped correspond to the same destination number. So seed number 10 corresponds to soil number 10. So the entire list of seed numbers and their corresponding soil numbers looks like this. With this map, you can look up the soil number required for each initial seed number. The gardener and his team want to get started as soon as possible, so they'd like to know the closest location that needs a seed. Using these maps, find the lowest location number that corresponds to any of the initial seeds. Find the lowest location number that corresponds to any of the initial seeds. So we have a list of initial seeds, these seeds, all right. And then we like need to do the map here basically, and then find the minimum, right? Sounds easy. People said that it is hard, but the only thing that is hard is like parsing the input maybe here. So far, I think. So seed 79 goes to soil 81, and then goes to fertilizer, and then lights, and temperature, and then location. Yeah, okay. All right, let's get our puzzle input also saved in day 5. And then let's go and solve this thing. All right, we can go back to here. Day 5. Let's start. You're going to write some code for it later. Tired of trying to make half-decent pixel art. Am I winning? Am I winning what? Is this Hyperland? No, it's not Hyperland. I'm on GNOME. Hyperland is a little bit too unstable. It crashes and uses too much memory. So that's why I'm not using that. Advent of code. We'll see. How do we describe winning though? Because I'm late for the leaderboard, obviously, right? And it's not like they actually ask us not to stream while the leaderboard is not full. I'm not sure how we can beat Advent of Code. Can I beat Bad Cop? How close is Bad Cop? Isn't Bad Cop's like trying to solve this for 3 hours already? I mean, the part 1 is going to take us like 10 minutes max. You know, it depends on how much I talk with chat here, I guess. Let's see, input, std, file system, read to string, input, day5, example. We start with the example. Gonna leave, don't want to be spoiled. Isn't it like 10 hours since it already started? I thought you already solved it. But okay, sure. Don't worry, it's going to take me like half an hour and then we like go like, oh, you have work. True. I forgot people have work, you know. It's hard to remember that there is such thing as work when you don't have one. All right. Okay, so we need to find the initial seeds. Initial seeds. Activate Linux. Yeah. Okay, we're going to find the initial seeds, which are in a format seeds colon and then space separated things, right? Okay. Let's see. So we are going to need to have lines, input lines. This is the iterator. So we're going to take the next line, lines next, wrap here, and then we are going to we're going to strip prefix here, which says seeds colon, unwrap that, and this is the actual data string, right? And then the actual data is going to be a data string. We're going to split ASCII white space, and we're going to map those by parsing into integers, right? And then we collect the initial seeds, right? So this is going to be a vec of seeds. What are the things that we actually have there? Let's say that they all look, well, we do have 0 here, right? So, but it looks like they're all at least not negative, so we can do a U64 maybe. And this is our list. Just use let input is input string input day 5. I can. It doesn't matter though. It doesn't really matter if I use read to string, if I use file system or not use file system. It doesn't matter. If I don't use file system, then I can like technically interact with my terminal instead and like read from a standard input, you know. It doesn't matter. It doesn't matter. Less to type. The amount of code to type, if I was to try to minimize the amount of characters to type, then instead of unwrap, I could like do something like, you know, trait like short unwrap, you know, and then I can do like, I mean, I just prepare this in advance, right? Like instead of unwrap, we just do U, for example, or W, right? And this is going to like do this. And instead of unwrap, I could do W here, you know, or I could just use Python also. Then we also like write less characters, right? But it doesn't matter. I don't care about the number of characters that I need to type, you know. You already get input string for free. It doesn't matter. It doesn't matter. Why does it matter? I will need to recompile my program if I change the input. And in this case, I don't need to recompile, so it's faster. Okay? Okay, let's get the input. We have the initial seeds. The next thing is going to be the maps. So we are going to do all the maps here, right? Okay. All right, sure. Is it always the maps are Let's take a look at the actual thing. Seed to soil, soil to fertilizer. It always ends with location. So it's all just a chain of maps, right? Okay. It's not the same thing because it will need to be recompiled if I change the input. Not that it matters anyway. Okay. Initial seeds. Let's just read the input, you know? Let's just read the input in a structured way, right? So we have basically we're going to do for line in lines, right? We're going to like build the current thing, current map, I guess. It's going to be optional map from one thing to the other thing, right? So let's do something like string because this is from, so like seed to like soil, right? And then the actual data to map, which is going to be a hash map. Is it going to be a hash map? I think it's going to be a B-tree map actually, from the start index and then into range and the length and the target, like the length. Okay, maybe instead of tuples I need to like actually give these structures names, you know. We'll see. Okay, so if line is empty, then we just continue. Otherwise we need to do what? Oh, if it's empty, then we like end the current thing, because that's how we... All right. If line is empty, then if let some map is current map take, this is going to be mutable. Then we are going to add it to like the actual input, right? So we're going to have the mappings, which is going to be a hash map from a string. So this is where we are going from into a hash map of where we're going to string, and when we're going over there, this is like the actual ranges, right? Let's call this ranges. Type ranges is this, right? Hash map from string into ranges.
Hi.
Hi. Okay. We are solving the advent of code, guys. For those of you who don't know what it is, here's the link of the problem that we're solving. And I'm just reading the input of the puzzle right now. So if we had a map, then mappings entry for... So the map is specifically from, to, and ranges, right? So the entry for the from, we're going to do or default, and then we're going to do to insert into to the ranges. This is how we are going to do, and then old, we're going to assert that we do not override some existing data, that this is the first time, but this is how it seems like it should be, just to make sure that I understand everything correctly. We're going to assert, all right, and then if the line is not empty, then we need to add to the current map, basically. So like otherwise, we are going to say that that we're going to basically match on current map And if it was some map, then we need to add to the current map. So if in case it is some, it is one of these lines. In case it's none, it's the original line. So we need to parse like from and to here. So if it's none, let's start with this one. We are going to find the -2, I guess. Okay, let's see. Line split once using the -2 right? Okay, this should be done, and then we say from and rest is going to be this, and then we need to do space map, right? That 2 is rest strip suffix. We're going to strip the suffix of the rest to be space map colon, right? Do my lines have the /n in the end though? Let's trim the line just in case, all right? So here's what we do. So now we know what is from and what is to, and we're starting the new map, right? So current map is going to be equal to some from, to, and the default stuff, default ranges, which is empty B-tree map. Okay, good. And then in case we are already building the map, then we're just going to read 3 numbers, right? So parts is going to be line split white spaces, right? And then all of those are basically U64s, so we're going to parse those into U64s, right? Those are the parts, and we are going to get the destination, and then we're going to find the start of the range, and then we're going to find the length of the range, right? And then we're going to assert that that's the end of the line. All right, so this is us just parsing the input, and we are going over here to do to the current map, which is from, to, and the actual ranges. Into the ranges of the current mapping, we want to insert at the start to be the range that goes to the destination and has the length of length. There you go. There you go. Insert returns option. So this is old, and I want to assert that old is none here. Okay. So this is us just reading the input. Let's see. Cargo run, day 5, part 1. Okay. We didn't panic, which means that I did read the input properly here, it seems. So now we just need to go over the initial seeds and do like the actually perform the mappings, right? Okay, so let's go. We literally just go and we need to find the minimum one, right? So initial seeds, we are going to convert that into the iterator, and then we are going to map the seed into the location, right? And then we're going to find the minimum one of those, and that is our answer. I'm pretty sure that I remember the statement being something like this. We're going to print the answer. In the end, now we just need to convert the seed using all of our mappings here, right? Using all of our mappings. Well, technically, we don't need this to be hash maps, but let's start originally with current. So like the current type of the thing that we have is the seed, right? So we start with the seed, and then we need to end up with the location, right? So we do something like while we have some like maps which is going to be maps get for the current type, right? So if we do have maps, so if we can convert our seed to something else, then we're going to do it basically, right? Current ID is seed. Okay, so if we do have the maps, then we are going to do maps. Oh wait, hold on. I'm not sure why am I so holding this way, because like the input is not going to change, right? And we already know that it's just seed to soil and then soil to fertilizer and then fertilizer to water. So like, why am I doing even the hash maps? Well, I don't know. Let's keep it like that anyway. So like maps, I'm going to basically assert that maps length is exactly 1. All right, because we can only convert seed to one other thing. So we're going to do maps values next unwrap. This is the actual ranges, right? So now that we know what ranges are for the current conversion, we need to find the one that we are in. So this is a binary tree map, where the key is the start of the range. So this is how we actually find the range that we are in. So we do ranges. Is it split off? Splits the collection into 2, and the given array returns everything after the given key, including the key. No, I don't want to split off actually. I want to have the range. Constructs a double-ended iterator over a sub-range element. The simplest way is to use the range syntax. So range min max will yield elements from min to max exclusive. Range mute. Do I need to use the range? I don't very often use this thing, but I feel like it should be the range from the current ID basically to the end, which is going to give me Actually, hold on. I need to find the range that we are in. And I'm doing the binary tree map based on where we are from. I feel like we should change the format here. Or maybe there is another method that we can use for the binary tree map. Or I could use just as a regular array and do a binary search on that. Current ID range. What else? Like, what can I do on a range? This is just the iterator, right? Like, I cannot go back, find the previous one, can I? No, I don't think so. So I want to find, like, our keys are sorted here. I want to find the last key that is less than or equal, basically. Wait, if it's less than or equal to the current one, so we do dot dot equal current ID, right? Because that's the start that that's like the correct start for the range that we are in, right? So I do something like this, and then for this range, I'm going to take the last element, which is the range that we are potentially in. This can be none, but we are going to filter that to check that we are actually inside the range. What is the range here? The range is yeah, so like we have the key and both the value, right? So we have basically start, and then as the value we have destination and length, right? This is the thing, and now we just need to confirm that we are inside this range. So, well, let's just get it actually. Let's just get it. Nah, let's not get it. Can I do filter map? No, but I can do and then, right? And then is what I can do. Yeah, and then. So if we have this range that we're potentially in, we just need to check that we are inside that range. So if current ID is less than start plus length, right? Then we are actually going to map the current ID into instead destination plus current ID minus start, right? Otherwise, we are not going to map anything. So in case we still have none, we are going to just keep the original current ID. So the ID is going to stay the same. And that is it, right? That is all we needed to do. And then the answer is the minimum. So, okay, in the end, hold on. Maps. Let's see, we are asserting, right? So like we are going to say current type is maps. I guess we need to do both next type and ranges is not values but just iterate, I guess. So next type is this. Okay, so we do current type is equal to next type, and that's how we have performed the conversion. We have converted the ID over here. Current ID is this is how we convert the ID, and this is how we convert the type every time. And then in the end we're going to assert that the current type is equal to the location, because that's what we want to find, and we return the ID in the end that we have found, and we find the minimum one of those. Okay, let's go. Part 1. We found humidity but expected location. All right, so we do have something wrong here. This assert has failed because apparently we did not find any mapping for the humidity. Why not? Humidity to location. So I did not find how to convert humidity to location. Is that right? There's no way. Hold on. Let's print out the thing that we have. Mappings. What do we actually have here? For the humidity, so temperature can go into humidity. Soil fertilizer. Oh, wait, I know exactly why. It's because in the last over here we don't have the empty line, right? So, yeah, I get it. We only do it on the empty lines, basically. So we do lines, and then I'm going to chain that with one empty line, basically. There you go. I'm going to do one empty line in the end so that I parse the last one. Okay, and the answer is 35, and what they wanted us to find for this example is 35. All right, so the example has passed. Let's remove this print. Let's run this on the actual input instead of on the example. And this is our answer. Submit. This is the right answer. All right, now we go to the part 2. How long did it take me? Actually, not that fast. Pretty slow. But okay. Part 2. Everyone will starve if you only plant such a small number of seeds. Reading the almanac, it looks like the seeds line actually describes ranges of seed numbers. The values of the initial seeds line come in pairs. Within each pair, the first value is the start. Hello, Josumusu. What are you doing? The values of the initial seeds line come in pairs. Within each pair, the first value is the start of the range and the second is the length of the range. So in the first line, we have two ranges starting from 79 and the length of 14. I see. Okay. Now, rather than considering 4 seed numbers, you need to consider total of 27 seed numbers. So the thing is still the same. It's just like with the input is much bigger now, right? What is our actual input though? How many seeds do we need to convert? Day 5. Well, these numbers look pretty big indeed. Okay. So we need to do it not for every single seed. You know, right now we're doing for every single seed, but that's not what we should be doing. Okay, it does look like we have something here. So how am I supposed to do that then? All right, now we actually have to think. How big are our numbers? Our numbers are pretty big. We have like 9 digits in the length of this range, which means that we need to be able to process the entire range at once, right? Um, well, I mean, we are going to try and process this range, and it potentially can split into multiple different ranges. Is the thing here, right? To have the range, then we're going to split into different ranges. It looks like the number of lines that we have is not that big. So like, what if we try to construct the original just seed, instead of doing seed to soil map, can we just construct ourselves a seed to location map in the same format that we already have here? For that, we need to be able to merge two maps like this, right? And in order to merge two maps like that, what we need to do is we're going to take the map below, and then we're going to overwrite on top of that some the ranges, right? So all I need to do, the operation that I need uh, is to get one range and one map and find and then they can become like nested and shit, which is bad though. Mm. Which is bad. Okay. I wonder like how efficient our solution actually has to be here. Um, I'm currently trying to think about the segment trees, but that's probably like the overkill. But we can go for it anyway. Maybe. What's the length of this? 200. So like we don't have a lot of ranges. We have like 50 ranges or something like that, and we have like 200 lines, which is describing us the map. We don't actually need something very efficient here. Forget how it's going. We just solved the part 1 of the day 5 advent of code. Now we're trying to think about how to solve the part 2 and how efficient do we have to be here. So yeah, basically all I want, I guess here is I'm just going, when processing this range, I'm going to intersect that range with all the range that we have over here, and then do it separately for every one of those. But that seems a little less efficient. I'm wondering if I should just go for the efficient solution here, which I think is the segment trees, the compressed segment trees specifically, if you know what that is. So we're going to have our maps and our segment tree. So basically, what this map is, for every range, we are basically doing something like on this range, we convert the original like number by adding some number to it, by adding some number to it. That's what our map is. So like in order to find the minimum, because all we need is to find the minimum one, right, on every single range over here, we need to be able to find a minimum value, a minimum index minus value on a range. Do I want to go like ultra efficient here, or do I not? One of the things that I can use is my RNG tree for the one of the lead codes that we sold the other day for that. Did Badcop solve this already? I'm wondering. This one actually is not that easy, I think. Unless you, like, there is a way... No, Badcop did not solve it yet. There is the straightforward thing here to do, right? But I'm kind of lazy to do that. Here is the thing. We have the entire range, the entire, like, the infinite range of numbers that we potentially have in this problem, right? And it's interesting how you do it. Yeah, so here's what you can do, right? So we want an efficient data structure which allows us to basically so the data structure that we're going to have like ranges here, right? Ranges, and like in this range, it's basically we say -1, right? Or in this range, we say like +3, because like that's how we change our ID, right? That's how we change our ID. Then in order to find like the minimum, once we have constructed our map, all we need is the minimum is always going to be in the beginning of the ranges, right? Yeah. So like this is going to be like in a tree like structure where in every node we basically calculate the answer to the problem, and then we can run queries on this data structure to find what is the answer. So like in this range, if the original seeds are in this range, basically, you know. Now the actual data structure, what do we need to update here, right? We basically start with an empty, the identity function, where every seed is just going into itself, right? And then we start with the last one, the map that goes to the location, and we update those ranges respectively. And then we go to the one before the last one, and we need to update it again. We can construct this thing pretty... I mean, how efficient do we want this to be? Because like we only have 200 lines of the thing here, which means that we only have 200 ranges basically in the data structure that we have in the end. So we can do like quadratic complexity based on the number of lines here. Or do we want it to be even more efficient? Or wait, hold on. Is it quadratic? I'm not sure. I'm not sure right now. Let's see what happens if we have an existing map. So like we have some ranges here and we have some numbers, -1, +3, something, 0, 5, you know, right? And what we want is we want to add to a segment here. So on this segment, the thing is going to be something like So we are mapping these seeds to something else. So we are mapping this to that area, right? Mm-hmm. The thing that I'm thinking about right now is like overcomplicated, though, is the thing. Maybe we should go for an easier solution first. Yo, bad cop. Thanks for the rage. Did you solve this one already, or did you not? You solved it? Why am I so slow? What do you mean, why am I so slow? Because I just started. Imagine not even solving day 5 yet, Omega lol. I know how to solve this one. I'm just trying to think if I want to do this like ultra effective solution here, or do I want to like make a quadratic complexity solution here. Your runs in 12 seconds. We are here to laugh at me. All right, you guys want me just solve it really quickly. All right, fine, sure. Let's copy this. Day 5 part 2. Okay, sure. Your runs in 60 microseconds in Rust. Set the timer. It's okay, you can cheat off me. You think I'm going to understand a single line of bash code here? I mean, I understand this line, and I understand this line. Oh wait, no way, you have functions here. Organizing your code, making it more readable, but then you still have this shit. My lucky picks. Wait, hold on. Is your solution based on RNG? Is your solution actually based on RNG? and then you just got lucky by running the thing. By running the thing 100 times. So the last time it ran probably for 12 seconds, but you ran it for like 100 times, right? Am I right? Did I understand it correctly? All right. Okay. So here's what we're going to do. We have initial seeds, which is going to be for the part 1. It's just a list of seeds, right? But now it's going to be the ranges, right? Let's just do the ranges instead. So can I do the iterator and make them go in pairs? Pairs, windows for the iterator? No, thing like that does not exist. Rust iterator, windows. Not actually RNG. Oh wait, hold on. I don't want windows. I want chunks, right? Splitting an iterator into chunks. Chunks is in slice. It is in iter tools. Chunks. Let's go and add the iter tools here. Chunks for slices. Yeah, but I'm like splitting white space here, and then like I have the iterator over the tokens. I'm not collecting those. I guess I could, but eh. Okay, so we're going to parse And then we're going to get chunks. Is my iter tools already here? Iter tools chunks. Iterator that shrinks chunks. Dot chunks. Why don't I have the dot chunks here? Import iter tools. Yes, import chunks. Chunks of size, this, and what is going to give me? Can we do like chunk tuples or something like that? Whatever, chunks of size 2, right? Chunk of size 2, and then we're going to map collect tuples. Collect tuples, it's also from iter tools. Collect tuple. It collects all items into a tuple of specific size. So this means that we still need to do chunks of size 2, and then we're going to map every single chunk, and chunk we're going to collect those into tuples, right? What is a chunk? Unknown. Amazing. All right. Oh, just dot tuples. Dot tuples. What is this? An iterator that groups the items in tuples of specific size. Oh, okay. So 1 to 5 tuples is 1, 2, and 3, 4. All right, good. Okay, we can do tuples then. Then we map start and length into start to start plus length, right? That's our ranges. Okay, good. That's how we read the input. Now we just need to parse, and instead of just doing seed one by one, we want to do it in ranges, right? Let's do something stupid. Not exactly brute force, but we're going to like solve for a range, which is going to be like a range and a range of type, and this is going to return us the answer, right? So we are going to, for every original range of seeds, because this is our initial seeds, we're going to solve for this range of seeds specifically, and then we're going to find the minimum one of those, and that's our answer, right? Now, how do we solve for a range of this type? We need to split the ranges into the parts that we are actually mapping into the sub-ranges, right? Okay, fine. So the maps are going to be equal to, this is going to be a recursive function, which means that I still need my mappings here. Maps get for the type if we cannot convert it into anything. This means that we are already in location. And we're just going to return the range start. Okay, otherwise we are going to map our like seed originally or something else into other things. Okay. Our input is that we convert only to the one other thing. So maps size is 1, length is 1, and what we are converting into, and the actual ranges are maps next. right? So we are converting our current type into something else, and those are the ranges that we can convert. Those are stored in a binary tree map for me based on the start of the range. So we want to find the first range that we are overlapping with and the last range, basically. Ranges, we are going to find the first range in our conversion is the one that starts before the last one that starts before or equal to our range start. So this is the first one that we can enter. Okay, yeah, first is this. If it's none, then it means that we're not interacting with anything, so we can just do same if we are not doing any mapping, that we just return all for the same range because we're not mapping into anything, but we have converted into that thing, right? Does that make sense what I'm doing here? I'm trying to find the first range in our current map, like soil to fertilizer map, for example, right? I'm sorting these ranges based on the start, and I want to find the first one that we are intersecting with, and then starting with the first one and ending with the last one, which means that I need to get all the ranges that start at least where the first one starts and then end before we end, and then start before we end, right? So range end. So those are all the ranges that we are actually intersecting with, or so those are in start, destination, and length format. Wait, what? First, this is the start and this is the end. Syntax error. What's wrong right now? Expected one of dot or an operator. Oh, it's let some else. I'm using a let else thing here. Okay, good. Okay, so over here we are doing all the intersections, right? Now we need to also figure out what is the last processed one. So last, because we not only need to do the intersections, but also the parts of our current range that are not intersecting with one of the ranges, right? So last processed, let's say that is like the current start of the range, right? So over here, the intersection is actually going to be the maximum of the start of the current range and the start of our range, right? Until the minimum of the current range end, start plus length, and the end of the current range, this range end, right? So we have the intersection range of our range and the range in the current map, right? So one of the variants is going to be this one. Solve the intersection range. Can we do the map here? Map. The ends into end plus destination minus start, because that's how we are shifting our range, right? That's our new range, and then we have converted into that thing, and then we have the maps. Arguments to the function are incorrect. Found a map. Oh, because this is the okay, fine, sure. Sure. Okay. Let's just inline this here, you know? The range that for which we're going to be solving. No. Let's say intersection start is going to be this. And intersection end is this. Advent of code breaks streamer.
I don't think this is right, but I'm gonna send it. Oh my fucking!
Why didn't you think this was right? You didn't believe in yourself. For some reason, you should believe in yourself. Hello, Milky. Hello. We guys are going to finish this advent of code, and then we're going to do the Bevy gem that we started. So we need to do this one quickly here. You didn't even test it on the sample? Was that for the part 1 or for the part 2? Did you solve part 2 without testing on the sample? Start, destination, intersection, and yeah, okay. So the thing that we are going to have here is intersection start plus destination minus start until intersection end plus destination minus start. That's the range that we're actually going to solve it for. Maps. This should probably have a different name. Okay, so this is us basically mapping the range as much as we can to one of the ranges in the map, right? And then we are going to solve this like recursively, and that's like one of our potential answers, right? So so the answer, and we also need the maximum answer. Is there a way in Rust, for example, I have Like if you have an option, right? Because in order to find the minimum, you want to like update your option basically with the new answer. So if it was none, then we want to set it to some, and if it was some, then we want to update it based on the comparison, right? Answer unwrap. But over here, what I want to do is answer dot. I mean, we can do a map or, right? Or we can do something else. Like, here's what I want to do. Update answer is going to be a closure, which is going to take the like new potential answer, right? And we're going to update our actual answer to be answer map or x. So this means that if it was none, that it is going to become x. Otherwise, if it was y, then it's going to be the minimum. Of x and y, right? Because we want to find the minimum. Something like that. Can this be written somehow shorter? Not sure. So over here we are going to update the answer with this stuff, right? And what is missing is the empty ranges basically. When we are not intersecting with one of these things, and for that, have the last processed, we are processing our ranges in order. We are processing our ranges in order. We are going to over here set the last processed to be equal to intersection end. And when we go to the next start, we are going to say something like update answer from, I guess, only if start is more than last processed. So it's like not empty thing that we want to update the answer with. We're going to update the answer with the range that is like not changed, and the range is going to be from the last processed to the start. Convert into mapping, because those are not being affected at all, right? They're just being the same. And those are the arguments to the solve function, okay? And one other thing that we need to not forget is after the last range in this, we potentially have one more empty one, right? So we say if range end is more than last processed, then we're also going to update the answer using last processed until the current range end. Okay, I think this is it. I think this is all the solution. I don't think I have been explaining it too well while solving, but I think this should be all. Amazing. We have panicked. Because binary tree... Wait, what? A range start is greater than range end in B tree map? Okay. So it means that when I'm calling the range over here, first 0 to the range end... First 0 to the range end... Is this the one? That is actually... Yeah, we only call the range method twice here. Over here, we don't have a start, so there's no way it's greater than the end. So over here, can first 0... Can I guarantee that this is exactly what's happening? Assert that first 0 is less then or equal, then range end. Is this the assert that is actually failing? Yes, it is. Okay, so how is this failing? First range is the range, is the last range that starts at most in our start. Hold on. I think I did something wrong here. We want to find the first range that is actually intersecting with us, right? So out of all the ranges, I want the one that starts...
Squiggly rings.
Squiggly rings. Hello, hello. I want to find the one that starts before us. I just realized that I don't even need to do that, technically. Let's start with an easier solution. This is just like me skipping some of the ranges, but I can just iterate over all of them over here. You know? Let's do it a little simpler first by just iterating over all the ranges that start before our end. And then over here we say if intersection start is less than intersection end, which means that it is a non-empty thing. We're going to update the answer. Is that going to run? Okay, there you go. We have some answer. How about we go... Okay, do we want to run on the example or do we not? Example. What's the answer for the example? The lowest is 46. Okay, it actually works, all right? Then we run for the actual answer, and the answer is that. Answer. Oh shit, hold on. This is not the right answer. I pasted my code. That is not the answer. Hold on. You gave an answer too recently. You have to wait. Hold on. I need to wait for... Shit. I need to wait for 54 seconds. Because I pasted my code instead of the answer there. Well, let's wait. Let's wait. 17 seconds. I don't have a clock with seconds anywhere. Is it done? Can we do it yet? Resend? That's the right answer. Okay, there you go. I told you it's easy. I was just like a little thinking of a more optimal solution. But obviously the input to this puzzle is a little too small for us to do a more complex solution, which I was trying to think about. We only have 200 lines here. That's like just nothing. So what is my solution? It's just exactly like it's like the brute force almost. We just so like in the part one, we just take one seed and then we map that seed to the soil using that map by finding the correct one here, right? And then we like do it like straightforward way, right? But in the part two, we basically operate on the entire ranges. So I find all the ranges that I'm intersecting with and all the ranges that I'm not intersecting with, and like I'm splitting my range basically into the parts. What what parts are like going to be mapped into like some other range basically next, and then I'm calling it recursively for like the next basically I'm solving the problem recursively for the remaining parts. You try to be clever and start from the bottom. Yeah, that's what I was thinking about. Like instead, I think you can do it. You can start from the bottom, and you can basically, instead of having all these different maps, right? You can construct one big map which goes directly from seed to the to the location, right? Instead of having all these intermediate steps, just make one big map. And to do that, you start you basically start on the identity function, right? And then you basically start from the bottom and do that, and update your data structure. And then here, and I was trying to like think how I can do this also efficiently, and I think you can do it like super efficiently using some sort of a compressed segment tree probably. Can you do a segment tree in Bash? Wait, do you know what segment tree is? The problem was that I had to plug my answers back into part 1 to get the actual answer. Plug my answers back into part 1 to get the actual answer. Oh, your program told you what seed, not the location, because you were going in reverse order. What seed is like... Oh, and so yeah. So you found the minimum seed that... you found the seed that resulted in the minimum location, right? And then you needed to like run the simulation again to find the actual location, which is the minimum one. Okay. All right. Day 5. Easy. Actually, not that easy. Took me an hour. Do you think the next advent of code is going to be like even harder? Is that how it goes? Or is it going to like, because it's actually a very big leap from the day 4 to the day 5 in complexity. You are scared? Yeah. You probably need to do a 24-hour stream to solve the next one. That is hard if you are going to continue trying your bash. I mean, it's probably not that hard once you actually know the solution to just try and write it in bash, maybe? I don't know. Like, can you do a binary tree, for example, in bash? Can you do a data structure? Something like that. Can you do a segment tree in bash? Can you do like a BFS in bash? A Dijkstra algorithm. Can you do something like that? Okay, as much as it was fun, I don't think I'm going for the more efficient solution because we need to start working on our Bevy Jam game. So here's what we're doing. We are participating in the Bevy Jam, just like Bad Cop is participating in the Big Mo Jam. How is your game going, by the way, Bad Cop? We are doing a different jam, which is called Bevy Jam. So we're going to make a game using Bevy Game Engine. And the theme for this jam is that's a lot of entities. So let's go and see what our game currently looks like. Your game is good, almost started. Nice. Nice. Okay, here is what my game currently looks like. Here's what my game currently looks like. So we have a map. You might not see it, but every single pixel here is a little bit of a different color. How does he do those transitions? Which one? This one? This is just the gnome. but yeah, okay, here's our game. We are having a bunch of pixels here. We click on those pixels. This is basically the resource which gives us like money, so we collect the resources and then we can buy bots that basically harvest the resources for us. So here's how it goes. We can like buy this guy and then it like does this shit, and then we have a bunch of those ants which are eating and harvesting money for us, right? And the map here is infinite, so that's like a lot of entities for us. And I'm not sure where exactly we are going with this game, but the idea is some sort of like a strategy, maybe automation, some game. I'm not sure. So this is what we have right now. We have pathfinding, where our little bots can find their way to the closest like tree or like the closest green pixel to collect. And we were thinking about how to do this better. So right now, what we have is one global pathfinding algorithm, like which works something like this. We are, instead of running pathfinding from every single one of these bots to find the closest tree, we are instead doing the breadth first search from the trees to the inside, right? But because the map is pretty big, we need to like split our BFS into like small parts and do it little by little, right? So our like global pathfinding map is only being updated like every once in a while. And in order for our little ants here to continue moving, we do also some local pathfinding for them in just a short range. So we do some short range pathfinding and long range global pathfinding, which is only like being updated once in a while. But I have been thinking about this, and I think we're going to do this a little bit differently. And here's what we're going to do. So imagine your regular breadth first search, right? So like you start from over here, from the cell, and then you go around, right? And then you go around, right? Like the wave algorithm and stuff, right? So we are doing this but in chunks. So we don't finish the entire pathfinding on one frame. We only basically process up to a certain amount of tiles in our BFS currently. And because of that, if while our pathfinding algorithm is working, the map is changing, then we're not going to actually see this change result in like in the global pathfind map, because we need to wait for the previous like pathfinding to reach basically the end of the map, which is going to take a lot of time. And then we're going to start the pathfinding from scratch. So here's my new idea. Instead, so right now basically we are doing pathfinding in cycles, right? We do the pathfinding algorithm, and then once it finishes, we do it again on the basically new map, right? But instead, I want to be able to inject and to like pick up the updates in the map while we are like doing the pathfinding, basically. And in order to do that, we can do it something similar like what Minecraft is doing, I think, right? So when you update a specific block or a specific tile, we are going to like recalculate. So for example, we know that what? Like, let's say that we know that the closest thing was like over here, right? And then for this tile, the distance is like 100. For this tile, it's 101. For this tile, is 102. But then But then we change our map and we spawn a new thing that we can pathfind to over here, which means that the distance in this cell is going to be not 102, but instead it's going to be replaced with 1 because it's like on the neighbors, right? And because we have updated this like distance, we also potentially want to update the neighboring cells. So basically we're going, so for the BFS we're just using a queue, right? And whenever we are updating the map, we're going to push into the front of the queue instead of the back of the queue. Well, actually no, not even in the front. I think we're going to have a priority queue instead. And the priority is basically based on the distance to the last like updated tile, you know, so that we are still going to like eventually calculate the distance to this tile from some far away tile, but that's going to take a while. But if while this is being calculated we update some other part of the map, we are going to basically do updates in the vicinity of that updated tile earlier than we do some long range pathfinding. And also primer craskle for neighbor edges. Nah. What was the prime algorithm again? No. The thing is, we want to do the pathfinding not just once, but our map is dynamic and it is being updated all the time. Prime algorithm is for constructing the minimum spanning tree, I think. No. Like, I don't need a minimum spanning tree. I want to find the I want to find the shortest or like the closest thing. Just pathfinding. Prims is for finding the spanning trees. So yeah, basically, here's what it means, you know. If we have a thing that we try to pathfind to, then we know that the distance to this thing from itself is 0, right? And then we basically go in waves, right? And we go onto the neighboring tiles and we say that the distance from the neighboring tiles to this tile is 1, right? And then we update the neighbors of these cells, right? And we say that like from this tile it's 2, you know. So that's like the idea, right? And we go in waves like this, and while it's going to take a while to calculate something for a very far distance, right, where the distance is 100. It's eventually going to work, but while we are basically calculating the long waves, is if during that the map is being updated, then we are going to basically prioritize calculating this to some like something that's like far, if you know what I mean. Okay. I think it should work. Hello, Davey. How are you doing? How's your game, Davey? Is it done? Okay, I'm just going to create a pathfinding plugin or something here. Pathfind plugin. Sure. Although I think it's going to be something generic because I want to do pathfinding to multiple different things. But let's see. Bevy prelude plugin. Okay. So what are we going to do? We're going to have a system. We already have right now the pathfinding. Here we go. We have a global pathfind and we have a local pathfind, just like I said. We have infinite map, so we have generated chunks and everything. Iterations left. Yeah, we need to do something similar to this. Something similar to what we were doing before. Cool, man. Using Bevy. Yes, I'm using Bevy because this is the Bevy gem. So we have to use Bevy for this gem. So here's what we want, right? I think I want it to be a generic thing. Let's just delete it. Let's just delete it here. Let's actually write it from scratch. You know, let's actually write it from scratch. Rust. Yes, Rust. Bevy is Rust. So for the pathfinding, I want to like be able to specialize how exactly the pathfinding works, I think. Specifically, what do we want? Hold on. Maybe I should not delete it. Should look at what I had before. So before we were basically doing pathfinding to the harvestable. Let's start with non-generic version actually. So we want to find for basically every single cell on the map which way is the closest harvestable resource, right? That's why we have the query of all the positions of all the harvestable things. Yeah. And then we store it, all the information about that in a resource. Resource. Extract global pathfinding. This thing. It's here. So it is literally we just find for every single cell what is the distance to the closest harvest and what is the number of ways. The number of ways I'm calculating because I want to do some RNG so the movement looks natural instead of just moving horizontally and then vertically. So instead of with harvestable, we can do something else. Pathfind T, like with T is what we can do. Make it generic. So this is the component, for example. So we are pathfinding two things with this component. Generated chunks is something that we need so that we don't continue pathfinding to the unexplored territory. And then we have a local queue of the positions that we want to update. But like I said, I feel like we're going to use the priority queue, which is binary heap, right? Binary heap. And this is binary heap of like, let's just call it update. So because we're going to attempt to update specific tiles, right? Struct update. we are going to update at this position. And then also we want to find the priority. So like I said, if we are far away from the last updated thing, then I want the priority of that to be smaller, right? Yeah. Okay, so distance, I think, is basically the thing that we want. Distance is just everything that we need. And in order for this to be in a binary queue, in a binary heap, we just need to specify the ordering for this. So implement ord for update. And in order to compare, we want to compare those in reverse order. So the other distance compare to self distance, actually, right? And then we want to implement partial ord. Partial comparison. This is going to be sum self cmp other. Okay. So then we need to also derive partial ac and ac for that to work, right? Okay, good. So now we have the binary heap of the updates, and some of the updates are going to be more important, some of them are going to be less important. I actually feel like we're going to require different systems here. So one of the system is the one that actually is doing the updates. Another one is the one that's inserting the new, so like when the map is updating, right? So let's see, detect map updates. Detect map updates. How do I do this actually? So I think for this resource, we are going to just have the queue there. So these are the updates that I need to do, right? Can I, oh wait, hold on. I also want the binary heap where I can delete from the binary heap to like update my priority for a specific cell. But at the same time, I feel like it's actually okay if I just do it multiple times. Whatever. Maybe it actually shouldn't matter. Okay, so how do we detect the map updates? We are going to, like, map updates are actually, we want to find the positions of entities which the positions of entities which either changed their position well, hold on. We want those that have the component that we are searching for. Like, what are we searching towards, right? But this is not the updates. I want specifically when something was changed, which means that the entity was removed or added. So it's not just all the entities with this component, but it is the entities that have their position changed or have this component just added to them, right? Does that look correct? And the other thing is, so this is detecting map updates for the entities that still exist on the map. But we also want to figure out if the entity has been removed from the map. Right? So over here we do entity and position. And also map updates, map, okay, removed entities, right? I want basically to query the, no, not query, removed entities, removed components. Removed components of the type T, because that's what we were searching for, and now it does not exist. So when it does not exist, I will store the positions of the entities with that in a hash map, and I will know what is the location that I need to update. And I also need the resource. So global pathfinding to the specific component is what we need here. So we're going to have like the data, a resource mutable of the global pathfinding for this specific component, right? So we're going to data updates. We're going to push new updates, right? But what are the actual updates that we have? So for entity and position in map updates, we do it here, right? Update new position 0. Let's have a constructor here. Because when we have an update in a specific position, we are going to start with a distance of 0. Okay. So like I said, these are the map updates when we have changed our position. So this entity has changed its position. We want to know what is the previous position was, right? And we want to update in the previous position too, because that also needs to be updated, obviously, right? In case we teleported or something. So this means that I need to store the previous positions. The previous positions can be stored in a local, maybe. Previous positions is going to be a local of a local hash map from entity into the previous position, right? So since this entity has updated its position, probably we say something like if we had the previous position for this entity, then we are going to push another update at the previous position, right? There you go. And then also we're going to update the previous position. Previous position, insert for the entity to be equal to this position. Okay, and then also the entities when they are removed. When they are removed. Hello, Rex. When they are removed, it's going to be similar. So for entity in removed, read, I think, right? Because this is the event reader. So for entity in the removed entities, we want to see if they were registered here before. So if we had the previous position, not even yet, because we can now just remove it completely, right? We're going to remove it here. So if we had some previous position, then we throw another update when we remove the entity. So those are the map updates that we have. And this should like kickstart our pathfinding, basically. We're going to always prioritize the updates on the map. When the updates are happening on the map, we are going to update accordingly. I guess also some of the other updates are the obstacles. So far, I actually have not been calculating any obstacles though. And we will need to like make sure that the detect map updates also detects the obstacles. Otherwise, it's going to not work. So pathfind iteration is going to like, we're going to have the data global pathfinding for this component. So we are not going to actually have the harvestables, are we? Well, we want to just update at a specific position, right? What is the closest harvest? I don't think we want that. Generated chunks. Generated chunks is something that we'll probably want. So, oh, I see. So before, what we were doing is we were doing the full pathfinding algorithm, and then when it's over, we start from scratch. But we don't want to do that anymore. And over here, this is how many iterations we want to do in one frame. Let's see. So while we have some update in our data queue of the updates, pop from the binary heap, right? Is that how it works? Do I call it updates? Updates. Okay, so we have a new update and we want to update in a specific position, right? In this specific position, we want to update based on the basically the surrounding positions. Or if we can just harvest this one, okay, so we are pathfinding towards the entities that have this component, right? That have this component, and we want to find those in the specific current position. For that, we have the tile map. Tile map. Right? So let's see, for entity in tile map, entities at update position. So we are going to find if any of the entities at this position are actually the ones that we're searching towards. So basically we want to do actually if the entities at, if any of those are inside the entities that we are searching for. So entities contains entity, right? So yeah, if any of those, then it means that the distance to the closest one is 0, right? So let's see, data closest harvest to the position this is, it's not harvest anymore because it's more a generic thing. So the distance is 0 and the number of ways to do that is 1. Okay. Remove this. Oh yeah, okay. All good. So, and then otherwise, if in this specific position that we want to update, if this position is not is not the thing that we're looking for, that we need to look at the adjacent tiles. So we are going to iterate over the directions like we were doing here. We're going to search for them into the directions. I think with the move directions, we can make this something like global thing. Just make it here. I mean, or I can just make this a public const. So move directions, we're going to import that. So next position is update position plus direction. If it's not in the generated chunks, then we're going to ignore that because we want to only do pathfinding in the generated chunks. Well, actually, hold on. We don't want to insert. We want to actually find what we're going to insert. So new data is going to be, in this case, this one, right? And in the other case, we're going to find it. So we're going to do data is closest. So distance is like something like the maximum one, right? U32 max. I mean, hold on. Distance should be like optional, I think here. Like, is it actually possible to find the thing, or is it not? I mean, hold on. Or maybe this is going to be optional here. Some. And over here we say none. We go over the directions. And we say that the next position should be in the generated chunks. And then we want to find match data closest. Nah, I should rename this. Rename this to, it's not new data, new closest, I guess. Over here, closest. So over here, we're going to match on data closest. Not entry, but just get at the next position. And if it is some closest, some next closest, and we do something. If it's none, then we ignore. So we actually just do if let, I guess, here. Did I already solve part 2? Yes, I did. Okay, so if this is done, then Then I want to update my new closest here, right? Okay, so I'm going to match closest. If it is sum closest distance and ways, if distance is equal to next closest distance plus 1, then we do one thing. And specifically what we do is we do ways plus equal next closest dot ways, right? Because we just update the number of ways to get to the closest thing. Otherwise, we just say that closest is equal to some next closest. But we update the distance. The distance is going to be next closest distance plus 1, and the number of ways is going to be equal to exactly the next closest ways. All right. There you go. So now we find the new closest thing, and we are going to figure out if we have actually updated the distance. Then we are also going to queue the ones next to it. I think. Yeah. So the old one is going to be equal well, hold on. If the new closest is none, does this mean that I should remove it? Yeah, I think I should remove it. Our map, okay. So the old one is going to be equal to data closest. I'm actually going to remove it here from the update position, right? I don't know. Let's do get. This is the old one. So and then we do if old is not equal to new. Which means that this should be partial ec, I guess, at least. So if we have actually updated something, then we are going to update it. So data closest, I mean match on the new closest. If it's some new, then we do data closest insert new for the update position, right? If it's none, then we do data closest remove update position. Update dot position. All right. So there you go. We have actually updated it in the map, and then we need to queue the positions next to us. So we do for direction and move directions. We are going to do this, and if generated chunks is generated next position, then we can add it to the queue, right? So data updates, push another update that we want to check position, which is going to be next position, and distance. It's not actually the distance, it's like the priority distance, right? Which is going to be update distance plus 1. It's not the actual distance to the thing, but it's like the priority that we have. Okay, I think I am actually done here. So this is the entire pathfinding algorithm, which can basically continue. It's going to prioritize the new map updates and update the pathfinding around that area before going for the further sections. And what we need to do here is we're going to have a trait app axt, I guess. We're going to implement anything for which is Bevy app. Implement app axt for app, I guess. So here's what we will want to be able to do for the app. We want to register pathfinding towards things with a specific component, right? So register pathfinding towards component C, which is the component, right? And that's what we're going to do here. And this is going to take mutable self, so mutable app. So in order to register pathfinding towards this component, we're going to insert the resource, which is global pathfinding towards component C, right? Phantom data is phantom data, updates is like default, and closes the default. So like by default we don't have anything, right? And we also are going to add systems which are going to work on update, and the systems are the detect map updates and pathfind iteration. Detect map updates for this component and pathfind iteration for this component. Okay, there you go. You just deleted 80 gigabytes from your download folder. What were you downloading? Your own VODs, I'm assuming? It's actually interesting. Hold on. I'm actually using 1.5 terabytes. What do you think I'm using my data for? You want to find out? We can do something like sudo dua e slash. Let's figure out what I'm using my disk space for. I bought this 4 terabyte SSD like a couple months ago, and I'm already used up 1.5 terabyte. It's not going very well. It looks like I'm going to run out of disk space like early next year if I never clean. Home, movie man, local. Oh wait, hold on. It's actually Steam games. Steam games. Steam games only 250 gigs. That's not even that much. Projects. Oh wait, hold on. Yeah, of course it's Rust. It's Rust. I'm just my target folder when I'm working is 140 gigs. That's yeah. You know, I don't even need to download things to like I can just generate gigabytes when I'm compiling my Rust. As you can see here, 140 gigs. That's cool. Okay, I think I am ready to use my new pathfinding algorithm, and we can do pathfinding towards multiple different things now too, because I have made it generic. The only thing that I need to do is to figure out where the entity needs to go, and for that we're going to query the resource, which is the pathfinding resource, and on this thing where I need to have a method implement for the pathfinding of t. The method is going to be something like I just need to know where to go from a specific position, right? So choose where to go from this position, and this is going to return me an optional position where we are going, right? Should it return the delta, or let's choose the direction? Sure, let's choose the direction. Okay, so we are going to have move directions, and we're going to choose out of them using choose weighted based on the weights, using the thread RNG, right? Thread RNG, and the weight for the direction is going to be the weight for the direction is going to be the number of ways for us to go from that direction to the thing, right? Yeah. Okay, so self closest get for the direction, no, not for the direction, but for from plus direction. And then we do map or 0, because if it's not there, then the chances we're going to select that has to be 0. Otherwise, it's going to be the number of ways to get from there to where we want. Expected option found result. So we need to do something like OK here instead. All right. Map updates. Dot iterate, I guess here. The return type of this call is reference to the position, previous position to insert position. Dot 0. Okay, I think this is done. Okay, now inside the game, let's see. I'm going to remove that pathfind movement to harvest and harvest. Okay, so pathfinding is no longer here. Instead, we are going to do app dot register pathfinding towards towards what? Towards the harvestable things. That's what we want to pathfind towards. And then we need to, so this pathfind, the old pathfind is no longer needed. Pathfinding is going to be a resource of pathfinding towards harvestable, right? Closest harvest, local path. Yeah, I don't want to do local pathfind anymore. I don't want to do global pathfind anymore. All we do instead of doing the pathfind, this is the direction that we're going to choose, right? So we'll literally just do pathfinding dot choose direction to go from entity position dot 0, right? And that's all we need to do now. So we don't need the tile map, we don't need the harvestables. It's going to be a simpler one. Okay, place and this is too many arguments. Okay, sure. Let's go into the cargotoml, lint, flippy, too many arguments, allow. Okay, well, I have remove all unused imports. Wait, remove, hold on. Remove all unused imports is only working on a one line. Okay. All right, after 1 hour of coding, is it going to just work? Let's see. So we're going to delete things, and then we're going to start and put the harvester. Well, I mean, our dude is going different ways here. We are going ways here. You know? We are going places. We need to like visualize. I need to visualize the actual distances here, I think. It also seems that like that I went inside the thing. Why am I going backwards and forwards? Oh, wait, hold on. I know exactly why. I know exactly why. The pathfinding, in order to we're not choosing the weighted here, right? We want to figure out over here. I want to filter it. If closest, I mean, or over here we do if closest distance is equal to closest distance, actually, because we want to go towards where the closest is, right? Then it's the number of ways. Otherwise, the chances we select this one is 0. So we need to calculate the actual closest distance here. And the actual closest distance needs to be what? Move directions. Map direction. Yes, filter map direction, self closest, get from last direction. And then we find and then we do map. We find the distance, and then we find the minimum one, right? Question mark. Something like that. Okay. Pretty sure that was the problem. Let's try again. But I want to visualize my pathfinding somehow. One thing that I see is I'm going into the thing, which I should not be doing. So let's do what? So choose. It should show us the distance to the thing and then the direction towards the thing, right? So maybe we call this method pathfind actually, and it should return optional like path, optional like direction, maybe. Let's do this. Abstract direction is going to be the direction is the IVAC, and then also the distance is this, right? Because I want to know the distance there. So I'm going to Can I just do the same thing here? Can I do the choose weighted based on the iterator? No, we can choose, but we cannot do choose weighted based on the iterator. So this is the direction, right? And then we say something like we return some direction is this, but distance is self closest at the from plus direction dot distance. That it? What is the direction? Is that better? So we are using it here, and if if we try pathfinding, then we're going to add the direction, but we're only going to do that if direction distance is less than is more than 1. No, hold on. Action. Just saw a spam commercial, threw up a little in my mouth when they showed the spam tacos. Interesting. Interesting. Did you know that spam goes into the can as a liquid? What is spam? I thought spam is those emails that I get every day. Okay, look at this. We have the pathfinding. And I'm pretty sure it should be much better pathfinding than we had before. It's not. Why are we going down here? Why are we going down? Hold on. We're supposed to go up. The closest one is definitely up there. And not down. Shit. I want to visualize my pathfinding. Probably. How would I do that? The dev dad. Hello there. Thank you for the raid. Welcome in, guys. How are you doing? What were you doing on your stream? I am participating in the game jam here, which is called the Bevy jam, right? As you can see in the title. If you guys don't know, this is the game engine for the Rust programming language. So we're writing Rust, writing Bevy, doing the game jam. The theme of the game jam is that's a lot of entities. So we are making a game with a lot of entities in it. Hello, silly squirrel. It's gelatin, meat, pork. Oh, so that's what spam is. Okay, invented during World War II to get mad to the soldier and to keep it from spoiling without refrigeration. Oh, I see. I see. It's like the cans. Okay. See, I did not know that it is called spam in English, because what we call them is like the conserves, because like that's what you do, you're conserving the food for longer, right? That's so we call it just that. Okay, and here's how our gem going, by the way. Silly Squirrel, if you just joined, I have just re-implemented the pathfinding completely, so that, like, you know how yesterday we had global pathfinding and local pathfinding, so now when we go back to just having the global pathfinding, but instead of doing it in waves, so like we don't do the pathfinding on the entire map, and then we do the pathfinding again on the entire map, but instead we only do the pathfinding whenever there are map updates, and I am prioritizing doing the updates on the areas that are like close to the updated positions, basically. So this means that I'm actually not doing any pathfinding if the map is being static, and I'm only doing pathfinding where it is actually needed. It's going to be improved what I'm doing right now, but it should be working. But I think I have a little bit of a bugs right now, because I think my guys are never going up. They're only going down. Hello, Jerem. So yeah, I just want to, I think, visualize my pathfinding right now to figure out what exactly we're doing wrong. It looks like we just never go up. We just literally never go up for some reason. So here's my pathfinding module. What we do is we detect map updates, and we start and we prioritize the updates around the updated positions, just like that. Just like that. Move directions. We still go on. We're supposed to go in all of the directions. How do I visualize that stuff? I can write the number on every tile, I guess. That shouldn't be too hard. Boom, 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 boom. Yeah, you know, like, let's do over here the debug commands. I'm going to spawn debug entities, basically. Let's do something like whenever we are actually updating something, right? Here's a link to spam. It literally linked to me the ad click. I don't think I can open it. It doesn't work for me. It's not opening. Okay, here's what I am going to do here. I'm going to spawn commands dot spawn. Spawn. So I'm going to spawn the text 2D bundle. Ooh, okay, text 2D bundle. Let's see. Text 2D bundle. Text. Can we do text 2D bundle like from section? So maybe text is going to be text from section. So section is going to be the actual thing that we have updated it with, right? So I'm going to do format, something like, or maybe update. No, not update. Something like, now let's do format, maybe. I don't know. What am I supposed to do here? Let's do new closest. Map or none. Closest distance to string. So this is the string that we're doing, and the style we're going to use the default one, and then the transform is the other thing that we want, which is going to be transform from translation. Translation is going to be update position as vec to extend 0, right? Should this be good enough? To extend 1, so it's on top. Let's take a look. Love the typing VFX. All right, well, now we have, see, this is we are visualizing the pathfinding now. I think my text is a little bit too big, though. But yeah, about the typing VFX, I was thinking about doing something like the typing sound effects too, because you don't hear my keyboard, right? If I remove the filter from the microphone, you are going to hear it, but there's programs that fake the keyboard sounds. I was like about to set it up, but then it's not that easy because I'm on Whale and it doesn't work here. The switch to Xorg, if you know what I mean. But yeah, I think the typing sound effects would also be nice to have. All right. What are we doing here? With scale. We do something like this. Yeah, see? Okay, now we have 0 in everything. Everything is 0. Okay, we are visualizing our pathfinding. The only thing that I want to do is I want them to be like the first third pathfinding triggers from point of change, so everyone goes towards it. Well, it should update it properly, right? So let's just do something like this so that we delete this debug. Debug thing time 0. Okay, something like this. Let's have a component of a debug thing. Component debug thing with the time, and we're going to have another system which is going to say despawn debug. So we're going to have commands, and we're going to have a query of of entities that have the debug thing component, basically. So we're going for entity and debug in query, and if debug... Wait, hold on, this should be mutable. I'm going to mutate the debug thing, I think. So if we're going to do debug basically 0 plus equal time, so we're going to basically despawn it after a certain period of time, and this is over here the timer. So time is a resource of time. So we plus equal time delta seconds, and if debug 0 is more than 1, then we're going to despawn it. Commands entity dot despawn. Just like that. So we're going to iterate mutably here, and this should be mutable. And this system needs to be registered in this plugin. App add systems on update despawn debug. Okay. All right, let's see how this is going to work now. So over here, we start with zeros and eventually it just despawns, right? And then, let's see. So we are going to click here and it's going to say that over here, the time is 1, right? We did see the 1 there for a second. This means that for this tile, the distance is 1 to the closest thing, right? And then over here, it's 2 and 1. So over here, we have a bug. Over here, did you see that? 3, right? It should not be a 3. And over here, it's a 1. It looks like we're not looking down when we're updating the tile. But this, see, it updated all 1, 2, 3, 4, 5, 6. It looks like we're only looking down or something. I think I did something wrong here. Well, I know exactly what it is. I know exactly what it is. I need to update this if we are... we need to do this. Only if the distance was more, or if it's none. Can I do an or here or none? I cannot. It's a different thing. Okay, I guess we can do none. And over here, we're going to move this if inside. So if distance is equal, then we update the number of ways. Otherwise, if distance was more than next closest distance plus 1, then we are going to let's say true here. Else false and non true. And this is going to basically mean do replace, right? So if we want to do replace, then we replace the closest with the new thing. If chain can be rewritten with match. Can it? You can reduce it to distance more than +1. Ah, okay. That's true. Sure. Let's take a look at it again. So we have zeros everywhere, and I'm just going to be updating. So this is now 1, and now they are both 1, and now they are both 1 there. It seems interesting that I'm actually updating 2 places here. I thought that I should be like updating only one of them, but yeah, see, like I'm changing my map, and my pathfinding is being like updated in the places where it needs to be updated, basically. And that's what I wanted to do. Exactly. So we are only doing pathfinding when necessary. But for some reason over here, I'm updating 2 places. Why? Why over here I'm updating this and also that? Oh, because I'm updating the number of ways to go to the closest one. That's why. All right. Actually good. R3 cheese, hello. That's why we are updating this place in the middle, because we are not only calculating the closest distance, but we're also calculating the number of ways to go to the closest one, so that we do the RNG. Okay, so here we go. Now we just do the path. Now we just do these things, right? And see, they are going, and we're updating the pathfinding. And see, like over here, we don't update anything. We don't update anything here because the closest thing doesn't change here, basically. So there you go. That's how we do it. You can see our pathfinding algorithm working and updating some areas now. And we are generating new terrain, so we're like doing pathfinding there for a little bit, but then we are only continuing in these places. That's cool, right? All right, I'm still updating it a little too much over here. We can make it work better. So here's the problem that we have right now, but I don't think I'm going to care about it, but just so that you understand what's happening, here's what we do. So imagine that we had 2 things, right? The harvestable thing here and the harvestable thing over here, right? So the distances, they are something like 1, 2, 3, 4, 5, and then over here it's 1, 2, 3, 4, 5, right? So this is like our current distances, and imagine that we are deleting this, and what needs to happen is that this should be 6, this should be 7, this should be 8, this should be 9, right? But because I'm doing it, because first of all, I am updating this tile specifically. So before it was at distance 0, right? Now it's going to basically update this tile by looking at neighbors, and and judging just by the neighbors, the closest thing over here, what is the distance 1, right? Which means that we assume first that the distance to the closest thing from this cell is going to be 2, because 1 plus 1 is 2, right? And then we like queue to update this tile too. And when we're updating this one, we're going to update this to be 3, because from both left and right, plus 1 is equal 3, right? And then we're going to queue this thing and this thing. So we're going to update it to be like 4, 4. And then we're going to update the closest thing to be like 5, 5 here. And then we're going to update to be 6, 6. And then we're going to update this to be 7. And only then we're going to update this to be 8. So like these updates, they are like unnecessary, but we're still doing it. But it should not be a big problem. I do have ideas how to like make it even better. But I don't think it should be. Like we'll see if this actually is a problem. As you can see, we are doing pathfinding like pretty nice right now. So here we go, new pathfinding, and we also made it generic, so we can register pathfinding to pathfind towards certain things. For example, we can pathfind now towards the base. That's what we were trying to do yesterday, right? Now, after collecting, we are going to, instead of just moving forward, we are going to have limited inventory, and we're going to move our collected stuff to the base over here. So they're going to be moving back and forth, and then back and then forth. All right. So, yeah. Pathfind. Okay, says Davey. Wait, Davey, how is your game? You didn't answer me. How are you doing? How is your game doing? Or are you moving now to work on Linksider again? Your game has transcended. What does it mean? Does it mean that it's released? Let me go on itch. Do I have the notification for Davy's new build? New game? No, I don't. Guess that's not what it means. Alright. Let's also remove the debug things here. On the pathfinding. I don't want those numbers to be seen, right? So we do something like if CFG false. CFG feature is show pathfind. Can I just do if false here? Okay, good. You got a team now? No, I don't got a team. Do I need a team? I'm not even sure what I'm building. You can make art for me? Do I need art for this? I think I can like just literally keep it redesigning on my pixel end. I'm not going to accept you to the team, Davey. How about you just work on the Linksider instead? There's some art that can happen there. Isn't it? Or like some other things that can be done there. If you make art for me, then it means that I have to do some work to include that art into the game. And right now, I don't have to because we just have pixels. Okay, what were we going to do? I wanted to like do pathfinding towards the base. The only difference about the base, is that the base is not one by one, you know? Yeah, so here's what we're going to do. When we're detecting map updates, we're pushing the updates to this position. So instead of doing these positions, we are going to do something like let mute update at, it's going to be position well, I guess I need this size here. So we changed position or changed size is what we want. Entity position and size. Size is optional for us. So the previous is going to be not only, it's going to be position and size here. Actually, So it is some previous position and previous size. So I'm going to do update at previous position and previous size. And position size. And previous insert, position 0 and size map or select to. I mean, or I can make size not an optional one. I don't know. Size 0. But it's too late. I already like reach it as an optional. So like if with the entity does not have the size component, that it's a size 1-to-1. So update at is going to do a new update. Distance 0 and position is xy. And we do it for x in 0 to size x, for y in 0 to size y. Xy plus position, like this. So this should make it so that we find, so we do path find towards those things that are not like 1-by-1 now. Okay. All right, so inside the game, we are going to now register pathfinding. Register pathfinding not only towards the harvestable, but also towards the base, right? Or what? Towards storage, I guess we can make it storage. So that the ends that they are going to try and pathfind towards the storage, we can make different storage buildings, and this is where they are going to like try. You still haven't gave up on your game yet. Easy, there's more to come. Didn't you just ask if you want if I want you to make art for my game though? Like, why did you ask that then? Okay, so here's we are doing pathfinding towards harvestable resources and towards storage, right? So we go our ants are going to go harvest and then store it inside the storage, basically, right? Right. So storage is going to be just a component. Because making some 1-pixel art isn't gonna take time. It is, like, choosing the colors takes a little bit of time. Not much, but it still does, right? Okay, so here we go. When we're doing the base, over here, we're spawning this storage. Wait, I think, I mean, sure. Let's just make it a storage here. So and now like our ants are actually going to have inventory. We have the max and everything, right? So here's what we were like going to do before. If our inventory does not have, So we are like trying to harvest, and if we cannot fit it into our inventory, then we're going to have this storing component, which means that that's what we are doing currently. This ant is now storing. It was idle, by the way, which means that oh yeah, storing. We are either storing or not storing. And we are idle. And we are currently doing this storing. Maybe it should be like not without storing. Like, what are we currently trying to do is trying to do the harvest, right? Maybe it's so like our end is in one of the states. Like, what is it currently trying to do? And in order to do this, our current thing that we want to do is to do the harvest, right? So it can harvest, but what it is currently doing is harvest, right? Harvesting. I know. Component harvest. So those are the two states of our ants: harvesting and storing. Harvesting. So specifically when I'm doing the movement to harvest, for example, right? It should be when we are doing the harvesting, right? Only then we are pathfinding towards the harvest. Otherwise, if we're doing storing, for example, it's going to be similar. Hi. Hi. Wait, maybe we just do a generic system like this over here. So ant movement, if we are, so like state component and what we're searching for. So like state, hello. Ant state is a component, and then we're searching for is also another component, right? So we are going to find the ants that are inside, that are in this ant state, and we're going to do pathfinding towards the what we're searching for, basically. And this is the ant movement. So yeah. So this basically means that we are going to do the movement if we are inside the harvesting state, then we are searching for harvestable things, right? And if we are in a storing state, then we are searching for storage, right? Hello, Bigorly. So those are the things, right? And we can do more things like that, like very easily. Okay. Now, hold on. Storing. So we are inserting the storing here, which means that we also need to remove the the harvesting, right? Because we basically change our state from being harvesting to being storing. I wonder if it can be done better in Bevy, right? We are doing the basically the state machine, but not as an enum, but as like the components here. I don't know. Remove harvesting and insert the storing is what we want to do here. So, and yeah, and then we also want to go back after we have finished storing. We want to go back to the harvesting, right? So we are going to do and store, right? Which is going to be the ants. We're going to modify their inventory. They have the inventory. They are currently idle, and they have the storing component on them. So they want to be storing. Right? We're going to need the tile map. Event changing path find to base, I suppose. Event changing path find to base. What do you mean by event changing path find to base? I'm not sure. Like I'm changing the state of the ant. So like I should not have both harvesting and storing at the same time because that's basically the state of the ant. I can make it an enum, for example, for what state our ant currently is. Is it storing or is it harvesting, right? But then I cannot expand it with new variants, and also I cannot filter it efficiently using the width here, I think. Because this is pretty efficient. It's just finding the proper archetype, I think, in the ECS. For and position and inventory in ants, right? What I want is we try to store, basically. We try to store. We find the move directions. This is also like pretty similar. Instead of try and harvest, we do like, you see, I'm doing it very similar here. We are looking at all the directions, and we want to find the storage, right? So storage is a query for whatever things with the storage, right? Component, because that's what we're searching for. So we are going to find storage. I guess we can query for the entity itself, whatever. Okay, so if some entity is try to store, so if we are trying to store in this entity, basically, right? So this is storage entity. Okay. So we are trying to store this here. And well, this is where we actually get the money. So we don't manipulate the money here. We're going to manipulate it here. Unless we like make it even a bigger chain of things. We're going to inventory dot current is equal to 0 and money dot 0 plus equal inventory dot current, but like in the other order, I guess, right? So we're basically moving from the inventory of the end into our like money directly, instead of like into the storage, because the storage doesn't actually like store things for now. We're not going to move in between the storages yet. We'll see if we're going to do it later. And then for our end, we need commands here. So we do commands entity this end. We're going to remove remove the storing, and we're going to insert the harvesting, right? That's how we go back to the harvesting state. Is that it? Let's see. It's probably not going to work right now, but maybe it will. End store. It will not, because I did not register the system. End harvest and end store. And let's see, it might be completely wrong here. So right now, I think what is going to happen if we just store an end, a harvester, is going to go towards, and it's not even going anywhere because I need to tell it what to do originally when I... So with the harvester, it should be initially in the harvesting state, I guess, right? I mean, we can spawn a base ourselves. But because we don't have a base, it's going towards the tree, the pixel, to like harvest it, but it's not going to find any storage. So it's going to like just stand still, right? There you go. So it's now in the storing state, but we don't have a base. So if I try and spawn a base somewhere, then it's going. There you go. So it goes collecting things and then back to the storage. There you go. It actually is working. And we can spawn multiple of them. So now they go collect and then I bring it back to the base. And if I want to, I can just spawn another base over here. A negative 100 money pog? Yeah, I know. It's because when I shift click, I can spawn more than I can afford. Okay. Now, as you can see, we are doing it much slower than we were doing before, right? Now we can do other things. One of the things that I don't like currently is... So what enemy or struggle will game have? I have no idea. We are not going to have enemy. I think the goal is it's going to be a peaceful game, basically. We're not going to have enemies. We just have a goal, maybe, of like maybe building something specific. But yeah, the thing that I don't like right now is that my ends, they're going through each other. So how about we make it impossible for them to go through each other? You are your own enemy. Yeah, they basically... we don't check for collisions at all. And we should. We should. Although, at the same time, I'm not sure if I want to, because, like, if we have a lot of things moving like that, Like, do I want to have collisions between the ends or do I not? It will change pathfind again. Yeah, exactly. It means that we're going to need to do a lot of like pathfinding here, which is probably not very good, right? So probably only the static objects that like the base, for example, we should not be able to go through the base or other buildings. Just wait for frame if it's stuck. I mean, we can try using the pathfinding, like doing pathfinding, ignoring the ends, but when we're actually trying to move, we are going to check for collisions. We can try that. We can try that. I think base is fine, just Z ends under it. I mean, yeah, technically going through the base is not that bad. Going through the building is not that bad. I mean, we can just, yeah, I guess we can just keep it like that. But, we can make them go through the buildings. It's not like a big deal, right? Maybe let's try focusing on something else. Storing the base. What should be the next thing? What should be the goal of the game, actually, right? Maybe we can try and thinking about that. Like over here, what has happened? Oh, I'm just inside the hole there. Actually, it makes sense. I could not store things. But yeah, see? I could even move through the pixels. For the most part, it's okay though. It doesn't matter for now. What do I want to do? Okay, we collect we collect the pixels. That's the first step in all the strategy games anyway, right? Maybe we need to do houses for them. Like, I don't know. We just need to do like we need to do more things, right? So far we just have the base and the harvester end. As you can see, we are progressing at a much slower rate now that we need to actually bring things back to the base. Now it actually is much slower, which is fine, which is good probably. In fact, I was going to make it even slower by making them not harvest immediately, but taking time to like collect the pixel. But I'm not sure if we want, if we don't want it. Um, we can try doing roads, for example, so that it's like faster for them to go on a specific route, like faster to go on a road than not on a road. But I mean, that's just like we need to figure out the goal of the game, right? Do we? I'll spend money only once a minute, but it needs to spawn ends automatically or buy age progressively. Okay, make a building that is going to spawn ants automatically. You are saying. Uh okay. But okay, but I think still automatically, but only if we like I think buy automatically is better than just spawn automatically. Let's make a building that just does the automatic spawning, right? Sure. Let's try that. Let's see how it works out. But still, like, it doesn't give us the goal of the game, right? It's just like us spawn automatically, but have limit. You think it should not be buying automatically? Should not be like... I don't know. I mean, okay, hold on. How should it work then? And then, like I was saying, it gives us more things to play with, but it doesn't actually give the game a goal, right? We can think of a lot of things, to like improve the sandbox. But what about a goal in the game? Don't you need homes for ants to sustain their population? Yeah, that's like also another thing. Like in strategy games, you want to be building those homes, and that's increasing your maximum population, basically, right? That you can go for. Yes. But then again, even that also does not give us. That also does not give us. Need to upgrade tree like Factorio or something. Well, I mean, Factorio is also like just a like it's also just a sandbox game, right? But they do have a goal, which is launching the rocket, right? So we need to do something like that. We need to figure out the goal of the game. What should it be? You know what I mean? Upgrade tree. Um, Goal: clear corruption from the world. You find it fascinating. The munch diamond shape after crunching the math works out to be circular based on path length. I need some advice for writing idiomatic Rust code. What can you give me as advice, please? Just write more code, I guess. Just practice more, and that's it. Clear corruption from the world. If you say clear corruption from the world, it means that we have corruption in the world, but we don't have it. Our game is literally, we just have a ton of pixels, right? And I think I like the simplicity that we start with here. We start with like do a base, and then we do a harvester, and then we can like do another harvester. Doing houses so that we can make bigger population is good, yes. Do you want only one resource in the game? If we can add more resources, but it doesn't give us the goal of the game once again. That's what I'm trying to think about. We can add a lot of things, right? I can have roads on which the ends they are moving faster. We can add houses which like increase the max population. We can make different types of ends because right now all of them they have one inventory space. We can make an improved version of them which can like hold more inventory, for example. That's something that we can control already. We can do different resources. We can do some factorial stuff where you need to combine resources to get another resource, right? But what's the goal of the game? I was never thinking about that when we started the project here. But anyway, no, it's not a problem. I need to write reliable and modular stuff, not just writing code. You see what I meant? For example, when you Tokyo crate, it's very well written and very modular crate, so I need to think about writing code like that. I still don't understand exactly what you mean. Just write more code and see how you can. I don't know. I'm not sure. Write more code or like explore some existing code. You can learn from the Tokyo itself, right? Just to read their code, maybe. I'm not sure what you're trying to do. Improve the and write better, more idiomatic Rust. I'm not sure what that means exactly. This looks like cellular automata. Yeah, I guess. Who thinks about the goal when mindlessly clicking cookies anyway? True. But we need to have more things to click on, right? Okay, sure. So basically our entire goal is to just make this number go up higher and higher, right? Like how do we start doing it faster, right? Seems like you have the makings of Ant Farm Simulator. Yes. The game is called Ants with an E because we're making it for the game jam, which and the theme is that's a lot of entities. So Ants with an E because short for entity. Race with AI with time limit. That means that we want to write an AI, and I do not want to write an AI. Writing in AI is not that easy. Resource management would work. Divert resources to a queen to create a new ant, or send some resources to expanding the base, so only a certain number of ants can use base drop off, making ants die if they cannot drop harvest. I don't want anything to die in this game. And I don't want things to die. I mean, we can just try adding new things. Let's just start by adding the things. Maybe we don't need an end goal because it's a sandbox. Maybe we actually don't need the end goal. But if you could buy things for money, either upgrades or more bases, moving bases, that's what these buttons are for in the bottom. So like I click on the harvester and this spawns a new harvester like this, or a base is spawning a new base so that they can bring their harvested resources to this base or to that base. They can now use both of them, and we're going to see the change of a shape because of that. Add a building that merges 9 ants into one larger ant. The only thing that I don't like about multiple bases, I don't want multiple bases like that. I want everything to be brought towards the one. I mean, maybe not, whatever. Maybe it's just a base. Red ants versus black ants. Give them a base for free. In the beginning, we can just make in the beginning just one base instead of spawning new bases. Because it's too easy to spawn a base, right? I cannot really make the base cost more. Because then I need to click manually in the beginning for a lot of time. So I think we should start with a base. You could be harvesting their way home and encountering harder and harder materials to harvest and need upgrades to get through. True. True. Okay. Let's see. What's the first thing? Let's write things that we want to do. Let's write things down. To do. So harder material. We don't I don't think it's going to be like a different resource, but it's just so like the further away we go from the start, from the middle of a map, the longer it takes to like delete the pixel, or like maybe it's still like a lot. Yeah, because we already can do the harvestables. They can link bases to create fast path and stamina. We can add stamina so that they can like need to sleep at night. That's like why the houses are there. But also like houses to increase max population, right? Roads to move faster. Map is infinite. Yes, it is. Maybe you need to find an exit or end goal, and you got to mine your way to the exit. Right now the map is infinite. And we can keep it like that. Houses to increase my max population, and we can do like upgrades. Upgrade to better ends. Right? How should okay? What should we start with? Anything else that we had? Anything else that we had? I think I want to start with a base so that I cannot actually put new bases, but I want to create temporary storages but I want to create temporary storages, and so that there should be like ants who just move things from the storage to the other storage. I think. Random scatter if DNA fragments for upgrading. Random scatter if DNA for DNA, like so we can like find other things other than just those, like other than just the resource. We can do some new other things to find. Another idea, under harvestable, you could find something useful to click on. Upgrade for better ants. I thought that we should have like actual temporary storage thing. And in order to make temporary storage work, I want those like ants who just move from storage to base, you know? So we have currently we have harvesters, and we can make also like the ones who just move things, you know? Maybe they have more inventory space. I think maybe instead of upgrading, I don't like upgrading too much. I would rather have different types of ants who do different things, I think. Those things you find should be under resources, so you need to dig them out. Yeah. Probably. What do we find though? Finding things. Let's start with the houses to increase the max population. That seems like the simple thing to do. Or let's actually start with a base. Let's actually start with a base. So this means that the generation of the chunks should be done differently. Let's see, generate chunks over here. So right now I'm just filling everything with the things, but what I want to do is if x absolute maybe if x times x plus y times y is more than 10, then we do this. Okay. Otherwise, if x is 0 and y is 0, then we're going to actually spawn the base. Harvest high energy food areas that call ants to immediately harvested. They're given a negative path length. We can do temporary buff. Hold on. So let's say that the ants, they actually need to eat, but then we need to like grow food, you know? Is that a good idea? So like they're not going to die though. They're just going to like buff themselves maybe. And be moving faster for a certain time. Is that a good idea? I don't know. Or maybe they actually like need to eat. I don't know. There's so many things that can be done here, but I'm not sure what I want. Let's start with spawning a base here. And type base. Actually, hold on. The thing that's we are spawning, can we just spawn over here without the matching? Commands dot spawn. Spawn So I'm going to have position, and I'm going to have end type. And this is also going to be a component. And then in another system, whenever we are spawning the specific type, it's going to fill the other things automatically, I think. Should be good. So we can spawn anywhere we want. So the end type should also be a component, I think. So we are going to add another system which actually like populates everything there. Add systems, update. End types basically is the system that I want. End types. So we're going to query the entities and their end type when we have added the end type component. You know? So we're going to for entity and type in query. We are going to do the match on end type. And over here, so we don't spawn, but we do entity dot insert the other thing. So like the position. So this is basically the configuration of the entity types here. Harvest high energy food areas that call all ends to immediately harvested, like by giving a negative path length, money per unit tile. Could have players spray pheromones to guide then nearby ends to say helpful objects. I don't know. Okay, so anyway, what I'm going to do here is I'm going to spawn on my generating chunks. Over here, all I am going to spawn is literally just the position and type base. And that's how I spawn a new thing. And then the other system is going to populate the other components of this thing. All I need is the position and the entity type. And this is not the ends, this is like pixels. I'm calling them money. We need like to rename our money to something else. Okay, so there you go. It's 0, 0, and then like we have this thing. That's our base, right? We can make the base at a -1, -1 instead. There you go. So now we start with a base and a little circle here, and we can remove the button to. We can remove the button for spawning a base. Spawn 1 and 2. I think it's okay if we click manually in the beginning. That's the The base does look... It looks like they're always going to the bottom left corner here. Need help to player what to do? Yeah. The tutorial... Sure. It's not the important part though for now. It's more of a polishing thing. We start with the base. I think the problem is that because I spawned without the size, something is wrong. Maybe the tile map. Let's see. Yeah, over here we changed the size. Previous. I think over here we need to do changed position or changed size. And then it should be good. Maybe it's not the tile map. Why you think start with one end is helpful? I don't know. There's a button here. There's a button here, and the like when you start clicking, it just needs to be a little more obvious that you need to be clicking here, and then the button becomes active, so you see you can do this. Okay, so that actually looks like it fixed it. Start with -1 end. Okay, so this is us starting with a base, and then the base button we're going to delete it. The base button we are going to delete. For loop over single element. Exactly. Start with base. Okay, and then we are going to do the houses, right? So we're going to do another type that we can do, which is the house, right? And house is going to increase our population. Let's do this because it's pretty easy. House. What's the theme? Theme is that's a lot of entities. How's your donkey gem going? Hello, duck. The theme is that's a lot of entities. This is a small gem for the Bevy game engine. In case you're wondering what I'm doing here. It looks like our big mode gem is not happening, so I'm doing this gem instead. We'll see. Maybe Bad Cop is still going to do something. Got to the basics of fighting yesterday. Nice. Not harvester. The house. Okay, so for the house, let's make the house like... What should the color be of the house? Brown? I don't know. Purple, sure. Whatever. House cannot move. House does not have inventory. House is not idle. House cannot harvest. Cannot do anything, literally. The only thing that the house can do is it's going to provide population. Provide population. And let's say that it can... So one house can give you like 5 new ends. Provide population. And maybe the base also should give you... maybe the base also should like provide 5 population. Sure, why not? This is a lot of entities. Yeah, exactly. We're making like a game where it's like a colony of ants. It's just like pixels right now. I'm not exactly sure where I'm going with this game, but so far we have an infinite map and an infinite forest basically, and the ants that are collecting the forest and bringing it back to the base. Okay, so provide population, and this is going to provide us the certain amount of population, right? Okay, I guess we're going to need a system which is going to like recalculate the population that we have, right? And store it in a resource. Or we can just calculate it. That's more of an optimization. We can just add them up together when we're actually like spawning things. Let's see, and type. So like disable buttons, right? We are disabling this button to spawn. We have the entity costs. So far we only use money. Entity type. Boom, 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 boom. So we also need the population here, right? Why did I make it a resource instead of it making it a method on the entity type? How much does it cost? I'm not sure. Boom, 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 boom. Let's just have it here. So the population providers is, we're going to query the buildings that can provide population, right? Provide population. Just like that. That's all we need to query, right? And max population is population dot iterate map population 0 sum, right? So I'm just going to calculate the maximum amount of population that we can have, and then the population that we can use. Population users, query uses population maybe. So that's going to be like a component on the end. Used population users. Can I just do the length here? So for now it's just going to take 1. Population for every single end. Can I not have the length here? I need to do iterate and then I need to do count. Is that what you mean? Max population, used population. And then we want to know if we can... or if we cannot do the... So in order to spawn an ant, we need the money, right? That's the first condition. And the second condition is going to be that we have the population. But that's also based on the type. So like the house we can still do because the house does not use it. Okay, let's see. As money. As population. As population is going to be equal to used population plus match on the type. Hello? Harvester 1.
Hello there.
Otherwise 0. So if this is still less than or equal than max population.
Hi.
Hi. Silly Squirrel. Hi, Davy. Lopey Gorley. Cannot find value type in this scope. Um. uh, okay, and then we also need over here to say that, so like the house is providing population, but the harvester is actually uses population, right? Okay, let's see. Let's see if this is going to work or not. So harvester, we have the money, and we can spawn it because this can provide us with 5. One, two, three, four, 5. Okay, so see, now this button is disabled because we don't have enough population. In order to do more population, we need another house. The only problem that the house does not have the amount of money that we need to build it. Base is not going to be able to buy, and house is going to cost... How much should the house cost? Is 30 good? I mean, the harvester costs 5. That's not a lot, right? 500? I think 500 is maybe too much. 1, 2, 3, 4, 5. And then we can start with our first harvester. And then we like continue ourselves a little bit. We buy another one, and then we buy another one, and then we buy another one, and then we buy another one. And then we still need to wait a little bit for the 30 to get, right? Now we can build a house. It spawned in a wrong position though. It's not where I actually put it. Why is it here? So now we can do more. Now we can do another house. Hold on, we cannot do another house. Why is my button disabled right now? Is my OS a custom Ubuntu? No. I'm not using Ubuntu, I'm using NixOS. Why is my button disabled to do a house? Because I had more population than I actually had required. I see. Because I used the shift click. Show population in the corner too? Yes, I should. Update population. So we have the population text. Population, this out of this, right? Current and max. Wait, how do I do a vertical stuff on the UI? We are gonna do center, default, and flex. Start flex and space around space evenly start stretch. Why can't you do push-ups? Because I'm lazy right now and I don't want to do push-ups. So current out of the max is the text, but it's just transform, isn't it? No, this is like HTML, I think. So like in HTML, when you have two nodes next to each other, which like text, right? They're just going to be in row, I think. Like how do you do vertical? I guess we need to make a list or something. I'm not sure. So we need to find the current and the maximum population, which is going to be done. Can I do it? Without copy pasta? I guess only if I store it into a resource. So we do it like this, right? And then this is max, and this is current. Unused variable money. Bit population text. Yeah, I don't need money here. Don't be lazy. How about you don't be lazy, Davey? Where's the game of yours? Okay, yeah, see, like, it's money 8, and then it's population 1 out of 5. Immediately, like, after that, I want it to be under instead. Bevy UI vertical thing. Is it align items? No. Bevy UI. What do we have here? Can I do something like vertical here? UI rect vertical. No. Should be list. Should be row. Flex direction. Maybe direction. Defines the text direction. Left to right, right to left. Flex direction. Row column. Defines how flex within a flex box. What's the flex direction and where do I put it? Is it inside the style here? Flex direction. Maybe this is what I need. Flex direction column. Let's try. There you go. Figured it out. Easy. Okay, yeah, we have money population out of 5, yeah. So like I can get money, I get the harvester. Now we have 1 population, right? And then we have 2, and then we have 3, and then we have 4, and then we have 5. And then eventually they give me the money to build a house. Now we can do 10. And then I build another house. Okay, so the house, for some reason, can I only click on tiles that are next to clear tiles? Actually, no. But maybe I should be able to click only on those that are next to. I don't know. Should we even be able to click on this ourselves? Should we even be able to click on this ourselves? There's literally no reason for us to do that, right? Other than the original 5 clicks. There's no reason for me to do it manually. It is because I did not put the position here. In fact, even the base does not have the position. Oh, wait. No. Position. Button. Button type. Placing. We are placing the end type. And we spawn at the position, the type. Yeah, we do have the position. Just give one end to start instead of... or I can give money originally, like give money to just be able to do one end. What do you mean it's because of the base spawn query? Base spawn query. I'm pretty sure that I'm spawning the house over here at the position that I'm hovering over. Query? What do you mean? I can do shift clicking to use more population that I can do. Position is there. Update transforms. Transform sprite position. Transform sprite position. And type. I do insert the sprite bundle here, right? Update position. Update transforms. Oh, wait, maybe I am updating transforms when it is changed here, right? Yes. But in fact, because I'm doing it later, it can be changed sprite, or it can be changed transform. Like, yeah. Well, I mean, this should not be changed. This should be like added instead. And if one of the position, moving, or size has been changed, yes. And these are added. I think this is the problem. One, two, three, four, five. 1, 2, 3, 4, 5. Okay. Right. Give me the money to do the house. Okay, there you go. Now it works. Figured it out. Now we need houses. The houses, we can change the size of them to be like 2 by 2, for example, I think. Second click to spawn ends after click. The button looks redundant too. Just spawn near base. Or random house, whatever. Okay. Maybe. I don't know. Like if we do it like in those strategy games, then we need to select the building and then we spawn it on that building. And right now I can just spawn anything anywhere I want. Like I should still be selecting the position of my house, right? This returns a reference to the captured variable which escapes the closure body. What closure body? This closure body? I mean, yeah. Hold on, what is wrong here? I don't understand. Cool, we already have a mutable and unmutable entity in the same time, I think. Nah. Captured variable cannot escape fn mute closure. Infer to be an fn mute closure. This is the closure. Oh, wait, hold on. I know exactly. It's because I am trying to do the iterator, and on the iterator you cannot do filter map. Like, because I'm only like trying to find one of them. So can I do in the iterator like find map instead? Yeah, I guess find map instead of filter map dot next is what I want here. Because then it's only going to be like called once. I don't need fn mute, I need fn once, I think. Maybe not. Um, this returns a reference to the captured variable. So the harvestables, this is a captured variable, yes. And this escapes the closure body. It does. Oh, wait, I know. It's because this returns not a reference, I guess. Something is wrong with the lifetimes here. What is the lifetimes on this method? Get mute. This returns a reference to the captured variables, which escapes the closure body. This is an FN mute closure. Closures can only have access to their captured variables while they are executing. Therefore, they cannot allow references to captured variables to escape. Move harvestable enclosure. I cannot move it. I cannot do a move here. Because then use of moved value is going to be the other thing. Hold on, I think I understand. It's just I cannot use the find map here. I think it's just find map, fn mute self item into option B. Yes. It's been a long time since I had something in Rust that I'm struggling to understand what it means. Query. So here's the minified example then, right? Let's see. We have something like let mute. Okay, let's just maybe try on the playground. We do foo, so we have a map which is going to be, let's say, we can just do a vec. I don't think it matters. We can do like even a slice, maybe a mutable slice to like integers, doesn't matter. So we can do vec. No, we can do like something like 0 to 10 dot find map index back get mute index. That's like almost the same as I'm doing. So this is going to return as optional mute i32. And there you go. The error is the same, right? That's the minified example of what I'm doing here. So the Rust compiler doesn't know the fact that once this has returned some, that the closure is not going to be called again. And in order to the closure to be called again, this should not be returned. Like the reference cannot be returned here. You know, even although for this specific thing, we are not going to call the closure again, but the compiler doesn't know about that. You know, so it needs to prevent the variable to escape the body. You know. So this was not the problem with the regular references, but with the mutable references it is. Back leaves more when foo, so it has nothing to do with foo. It has to do with this closure specifically. Because we can definitely do veg get mute 0, for example, right? If I comment this out, it's going to compile. Like, it's not a problem, you know? But it's not the problem with that we're returning it from the foo. It's the problem that we are trying to return it from the closure here. Because the closure needs to continue to live even after I return something from this closure. You know what I mean? The compiler doesn't know that once we return something from this closure that is like sum, it's not going to be like called again, so it's safe for this closure result to reference the captured variable. Now how do I fix it though? The way I fix it is I just find the one where this is okay, right? And this is the entity, and then we say try to harvest is harvestables dot get mute over there. Map. Like, if we do a map here, because this is fn once, then it should be like good enough. Entity. Consider the reference in the borrow. Yeah, sure. And over here we do okay. I guess we do unwrap here because we checked that this is okay. So like, because of that issue, I need to like duplicate my code here a little bit. We first find the entity and then we get the mutable thing one time, you know? Then define the correct thing and then get the mutable reference, which is a little ugly, but all right. And yeah. Okay, what was I doing anyway? I forgot what I was doing. What should we be doing? Okay, so we have these, we have houses. Also, I want to used population, call this current population. This is going to be need population. Is this? So if need house population is need population is equal to 0 or that. So that if we overflow the population by shift clicking, I'm just going to use it. Even although that's a bug in the game right now, I'm going to use the shift clicking here to spawn a bunch of things so that we can have the money. And then we can spawn more houses. House placement. Wait, what's wrong with the house placement? What's wrong with the house placement? We can do houses. The only thing that I'm not checking right now is that I'm not placing a thing over an existing, over something that exists. Should our ants be going through the houses? What do you think? Or should they be blocking? I think it would be more fun if they were blocking. they are static objects, so it doesn't make much sense. You think they should block, but you understand that's more effort. It's not that a lot of effort. We can try doing that. I changed a bunch of code. What did I do? What did I do here? What is the last? Okay, well, this is population is what we did. Okay, let's make things blocking. So in order to do that, we are going to go into the pathfinding and we are going to see if anything is blocking, literally. So on the pathfind iteration, we need to know if blocking entities are in the way with blocking. So here's the component that we're going to have. Blocking is the component. So we are just going to say that over here, if blocking, or I guess if tile map entities at the position are blocking, then we cannot go here. And that's it. That's it. We just need to do the blocking component and we're going to be going around the things. It's pretty simple, I think. Searching for this, and these are the blocking. And now we just need to add this component to some of our entities. We can make the ents themselves to be blocking, but I don't think we're going to do that because that's too much recalculation of the pathfinding. Mouse over here, we just do blocking, right? And we can make, I'm pretty sure like the base, if we make the base blocking is also going to be better. So there you go, let's go. This should be it. I think that should be it. I think this should be it. Let's try spawning a house over here. And then spawning a harvester over here. Let's see. We should... Wait. He just went through the thing. Okay. It didn't work. It did not work. Why not? Disable buttons. Also, how about we never disable buttons for now? Just to test things. Hold on. Hold on. Pathfind. If it's blocking, then it is none. So if it's none, that we are removing the data, which means that we don't know how to go from there. Let's do the if true here. And we are going to actually see the data in that case, right? The debugging. Okay, there you go. There's a little bit of like the pathfinding stuff. We should probably make the pixels themselves to be blocky. Okay, here's our pathfinding data. So if I make a house here, it didn't update anything. It didn't update anything, but it should have. Is it because this didn't work? It is not actually blocking? Is it because it is not actually blocking? Or is it because I did not detect map updates there? Oh, hold on. It actually is because I did not detect map updates. Right? It should, so like, yeah, the blocking things should be detecting the update. So with T, um, changed blocking, I guess, with T or with blocking. We need to do updates when we spawn a new blocking thing. And removed components are removed. And we want to remove the blocking to also be there. Right? I'm going to do the removed first. Removed read, and then we chain it with removed blocking. Read. Okay. Okay, let's see. So now if we do something, and then I do a house here, now I have updated. I think I have updated a little bit too much. You are doing more procrastinating on Game Jam. Congratulations, I guess. What is this? Wait, did you make it into a video? It's not just a VOD, right? Okay. Nice. Is the jam still happening? Or are you like doing your Bash things? You should, like at this point, you should try making actually a game in Bash. I guess. You never tried that, did you? Jam is still 10 days, I guess, yeah. Update at previous insert. One of the things that I wanted to do is to make the collectible things themselves to be blocking. So we're going to do the generate chunks, and when we generate chunks, these things, they are going to be not only harvestable but also blocking. There you go. Because I think we update a little bit too much of the pathfinding here. House. There you go. Okay. So I think it should be working now. I should remove the debug data. But I think we should not be moving through the houses anymore. So if I make a house here, people will not be moving through it, right? Seems like it's working. I think it seems like it's working. Let's make it like this to make sure. Yeah, I think it's working, right? What if I block everything? They're just all going to stop. That caused a lot of updates. And then we panic. Oh, the distribution uniform. I see what's happening now. So we do choose weighted. Because like for pathfinding, I'm choosing the out of those that are possible, and if nothing is possible, then the total weight is going to be 0, and it's not going to work. Can I do choose weighted? Can I try choose weighted so that it doesn't panic? Closest distance is the minimum distance. Wait, what actually happened there? What actually happened there? Oh, I see. Okay, I see. We go into the infinite distances. We actually go into infinite distances in case like I am recalculating something that is now unreachable. I'm actually going infinite, and that's exactly what's happening here. It is non-finite. Over I-32. Well, I thought that's exactly the reason why I am using for my RNG for the number of ways I'm using F64 specifically, so that like I want some relative precision. I'm okay with it overflowing, but it actually goes into infinity, like, you know. I don't want to know the precise number of ways to like go to the closest thing. I just wanted yeah, but this thing overflows, you know. Can I do try choose? Maybe not. How do I do this? Like I need to check that if it is let's see. Maybe if let sum closest is mute closest, and if closest distance is more than, let's say that we only want the max the distance to be like at most, I don't know, or we can do the number of ways to minimize it. Let's see if the distance though is equal to U32 max. I guess at least this way we can make it so that closest is none, you know? Loaded chunks only? Yes. I mean, we are only adding one here, so we can basically guarantee that we are never going to the maximum, at least. But for the number of ways, I'm going to do c ways is c ways dot. I mean, sure. Let's. This is how we go back to none. I should still like. I don't know. Let's do 1000 here, because like, yeah, we are going to do too much updates if we're trying to like close off the area that was reachable before. Now it's unreachable. Everything is going to infinity. So let's at least do it this way. To do. But the number of ways, so it doesn't overflow, we're going to do ways is ways plus next closest ways. And over here, I'm going to just take the minimum to 10 to the 5, you know? Maybe. Like, I don't care much about the big numbers there. The reason I'm calculating the number of ways at all is to just have a more, like, normalized movement. Okay. Looks like it's working now. Okay. And let's if true, change it back to false because I don't want that debug information anymore. And disable buttons. Let's bring back the disabling of the buttons. Okay. We have houses. Houses should work now. Let's just try again, closing the area off. Pretty sure it should work now. Close it off. And now they're all going to stop because they don't know how to go to the base. All right. Okay, good. Blocking houses. Okay, now we have blocking ability for our pathfinding too. As you can see, it was pretty easy. Pretty easy. What is next? What should we do next? What is next? Harder resources. Harder resources are pretty easy. I thought I already like started implementing it, by the way, for whatever reason. So like we currently have harvestables, right? And right now, every single harvestable has one resource inside, but let's just make it more and more harder resources as you go away, right? So what should it be? What should the formula be here? What should the formula be here? Should it be the formula, or should it be like noise? Should it be what? I don't even know. I think it should be like both based on distance, and we can add some noise on top of that, right? Do we have noise in Bevy? Noise? Noise? No, we don't. Berlin, that shit? Yeah. And then the color that we're doing can be based on the current something, I don't know. The amount of resources inside. Okay. Let's start with a formula though. Let's start with a formula. It's going to be X and Y. Let's just take the length of that. How do you calculate the length? Distance? Length? How do you get the length of a vec? Oh, it's IVec. Yeah. You can do just a vec, then you do the length. Yes. We do the length. And then we like floor that. Or we can just convert that into an integer, right? And then we can add 1 to that. But before converting into an integer, we can divide the length by 10, for example. Now, by 10 it's probably like too much. Let's do that by 20. It's going to be more and more. Noise could be simulated with a smooth stepped random number. There's a crate for noise. It's easy. Doing noise is easy. I don't need to like think about it much here. I can just add a library. How do we visualize that? How do we visualize that the resource is harder? Darker? Okay. And then as we collect from the same resource? Stiffer? What is stiffer?
Stiffer.
I mean, yeah, but like visually, how do we visualize the stifferness? It should be based on the like the color here. Maybe the harvestable. Maybe harvestable should be opacity. Yeah, we can try the opacity. Let's do this. We're going to add systems on update harvestable color system. So here's what we're going to do. Harvestable color system. We're going to query good morning code monkey, I guess, right? Wait, is it good morning or did you still not sleep? Query sprite color. Where is the color of a sprite? Just the sprite. Okay, so I'm going to query the mutable sprite where and the harvestable, where we have changed the harvestable component. So we are going to change the color when we change that stuff. So for this is going to be mutable. For sprite and harvestable in query. Change color, but make them also dark, harder to break. They are exactly harder to break already. I mean, it's not like they are not harder to break. I am making them more dense, so there's more resource contained in it, which means that it's going to require like multiple people, multiple like harvests from them. You know, because our ants can only harvest one thing at a time. So if this thing is like the second tier, then we need to harvest from it 2 times before it actually disappears. So yeah, we do sprite dot color dot alpha set alpha. Did we set the alpha here? I guess we set the alpha here to something based on the harvestful.0, right? So harvest counter. Yeah, it's kind of a harvest counter, but maybe we are going to have ants that can harvest like multiple at a time. Like if I increase the inventory space, then like different ants are going to like harvest them faster, you know? But yeah, it still has multiple harvests. How do I change the color though? Hold on. Based on just a number. Was it called ant, like entity? Or is the game's version of ant? Both. And that's why it's called it, because it's both ants and entities. Lerp. Lerp what? Lerp what? I think we do this divided by like 1, like 10. Let's say that's 10 is the maximum one. And that's actually like the opacity. Maybe. Minimum of that and 1. Just multiply the green by the number of resources. Like kind of what I did. But like we can technically go into the infinity, so I'm going to stop at 10. 10 is going to be the maximum opacity. So there you go. There you go. Here's our map. See? And it like stops there. Maybe we should start not at 0.1 opacity. Maybe we should start at something else. And then we can also like add noise on top of that, right? Let's see though, over here. We can do something like 0.5 plus 0.5 multiplied by this, for example. Right? Is it this still too light? I don't know. I feel like we can have even less. So let's do 0.8 plus 0.2 multiplied by that. We're still going to see the difference, right? I mean, you see it, but it's more subtle now, right? It's like this border is now more obvious, right? That's good. Let's add noise on top of that. Cargo add noise. Hopefully we are not going to rebuild everything. Okay, it looks like we're not. Good. So let's add the noise resource somewhere. Game app, insert resource. Derive resource, extract noise. So I'm going to use Berlin noise. No, I'm not. I'm going to use open simplex noise. I think this one is better. Insert resource, noise, open simplex, new, red, RNG, generate, just because it's going to be a random seed. So there you go. Now we are going to use that resource in order to generate our chunks here. Noise is resource noise, right? Let's see. Implement for noise. What do I want to be able to do? I want to get at position, which is going to be ivac2. That is going to give me the floating point number like that. From 0 to 1. Self 0. Noise fn get. So the point here is just position 0, position x, position y. And convert to floating point number like that. Open simplex is not implemented. We want f64 here, I guess. Okay, there you go. This is our noise. Is this numbers from 0 to 1 though? I don't remember what the noise is actually giving us. Is it from -1 to 1 or is it from 0 to 1? Well, anyway, let's go over here, and we are going to add some noise here. Noise get at the position multiplied by 5, maybe. I don't know. Maybe. Wait, hold on. This should be not iVec2. This should be the vec2. Like that. So we position as vec2 divided by 5. I don't know. Some formula is what we need here. This is the position. Position length squared if this is more than 10. Okay. Mixer. What's a mixer? Okay, there you go. Now we have a little bit of noise on top. We can combine multiple different noises. This noise and then some bigger kind of noise, maybe. Do we even need the basing on the distance then? I don't know. I mean, I just want the ones that are closer to be... be something. I mean, we're not even going that far anyway, right? I mean, not yet, because the game is too boring to play until we actually harvest that far. Okay, well now we need to be able to harvest at faster speeds, I think. Now we need some upgrades. Because we're not progressing very fast here. To the outside. We're not even using our infinite map. Now we are being too slow. We will need some upgrades. But I think, I don't know, I feel like my head is about... I'm about to have a headache. So I feel like stopping for now. We had a good progress so far. The gem is going for 6 more days. There's no need to rush. I want to go rest right now. I think. I'll think about what we need to do. But it looks like now we actually need to mine faster. Now we actually need upgrades, right? Now we actually need upgrades because we're mining too slow. So, let me commit that. What did I just do? Some noise stuff. Okay. Push that. Let's see. Is anyone else doing the Bevy gem right now? Maxi says, I'm never doing gems again. Maxi started doing the Bevy gem and then surrendered after the second day, it looks like. Okay. Make outposts or mines or whatever you want to call it, and they have to work to get to them, basically building roads, paths. They will all be working towards the waypoints. Yeah. And then from the outposts, I think someone, so like some other type of entity needs to move from the outposts to the base. Somehow. Because I think everything needs to go to the base still. Like, you know, in some of the strategy games, like in the Age of Empires, for example, right? If you build a mining thing, then they are not, like, when you collect your gold, you just need to move your gold to the closest, like, mining thing. Oh man, if they had a limited life cycle. And age just born are slow, and then after harvest, old age slows them. They had a limited life cycle. But then if they have like the theme is a lot of entities, so we should like make more and more of them. I don't think we should be like killing them off. We should just make more and more until the computer lags and explodes. And that's what the game should be. You know? Bevy. Jam, day 3. Okay. Anyone else? Rust. Mm. Old age slowness like 80% peak. No, not death required. I don't know. I'm not sure about the age. Like, nah. Like, I don't see a reason to add it. We don't need to slow them down. I need them to be faster, but not in the beginning. So we need to like work to get the upgrades. We need to upgrade, not downgrade them. Right? All right, let's go here. Go here. Some more Rust for you guys. This is not a game jam, but doing some Rust. Twitter clone in Axum and Rust.
Also get the count.
Have different resources that they are bringing back to the base, X number of some resource, and you can upgrade. There is a lot of ways we can do upgrades, yeah. I'll try to think about what I actually want, and then I will come back tomorrow and we will continue. Bye.
Oh, this is going to be interesting. So I need to do the exact same thing I did before. So with the group ID.